feel to it.
Yeah, it's got an almost improvisational tone.
This semester on Stat 201, prepare yourself for YouTube, because we're all zoomed out. Kahoots and special guests, Tiny Brian, Puppet Shark, Evil Moobot,
I am Moobot.
Morty the Rabbit, and more. Super Statistics Bros.
Hey everybody, how are we doing? It is winter and we're getting ready for the final. We're not going to do the Kahoot yet. Phone's ringing, I swear, in the background. Oh my gosh, Kahoots. Oh my gosh, so much going on. Who's here in the chat? Anyone here yet? I saw there's people watching. We'll start some review. It's cold outside. Molly, good to see you. Molly, good to see you. We'll throw some Moobot points out. Let's say Kahoot review started. Kahoot soon. Click here. Sending out links right now to students. Kahoot starting. Our review started. Kahoot soon. Molly, do you have any questions? If you have questions, we can do them. We'll start the Kahoot at noon. You need to take notes of what we're doing, though. Let me say in Stat 201, at Stat 201. Stat 201. Oh my gosh, that's not Stat 201. Stat 2. Stat 201. And reviewing now, live on YouTube. Also, Kahoot soon. Click here. Click here. Where's the link? It just says click here. Has anyone joined in? If you've joined in, Molly has a question, I think. Let's take the question here in a second. So copy link address. 1 second, Molly, and then we'll answer that question. There we go. Reviewing live. There we are. I was trying to go back and look at confidence intervals, and the questions with the t-value still confuses me. Let's talk about the t-value for confidence intervals. So video description right here for 33 confidence intervals and t-scores. Okay, so let's bring up some notes. And 1 second right here. There we go. And let's go over and start reviewing. Okay, confidence intervals with t-scores. Molly, do you know every bit of the notation right here? Like, what is each one of these things? How is it described to you in a problem? Can you name everything there? How about everything here within this problem here? What is everything inside of this problem? You know every bit of this inside of this problem down here. If you don't know anything inside of it, please let me know. Kahoot. If you don't know, please let me know. But you should know every little bit of this. So these are two confidence intervals. The first confidence interval is a confidence interval to estimate the true mean. Nice job, Clay, right there. Y bar, and then you got to make sure, and Clay's got them, Y bar is the sample mean. Now, each of these are the estimates. Y bar 1 minus Y bar 2 is the estimate of the what? Y bar 2 minus Y bar 1, or Y bar 1 minus Y bar 2, is the estimate of the what? What are we trying to estimate with the interval down below? The interval up above is trying to estimate the mean. It tries to estimate the mean. So it's trying to estimate mu. So what does that mean? It means, like, I want to figure out how tall UT students are. Well, I'd make an interval and I'd estimate somewhere between 5'5" to 6 feet tall is the average height of a UT student. So I would be estimating the true mean height. My guess of the true mean height is Y bar. Y bar would be what I see in a sample of, let's say, 100 students. The 100 students would be something like my sample size. I spoke to 100 students. S would be the variation or standard deviation of those students, which would be like they had a standard deviation of 3 inches. The t-score we'll get to in a moment, but the t-score is based on a % confidence. So the star means how confident you are, and then the t-distribution has a certain shape based on its degrees of freedom. The degrees of freedom formula is written out for this one, which is n minus 1, sample size minus 1. For my 100 student problem, the degrees of freedom for the t would be 99 degrees of freedom. But what, and someone answer in the chat, we're throwing out those mu-up points, what is this second interval trying to estimate? So if you're here, tell me, what is the second interval trying to estimate? The first interval is trying to estimate the true mean, not proportion. Good guess, Molly. A proportion interval we do in the class, you are correct, and we throw out some points for that. Good guess. Proportion interval does not use t because Mr. T is mean. He's mean, and great job, Drew, right there. Drew got it. We'll throw out more points. So the proportion interval, David, good to see you. The proportion interval is p hat plus or minus z star, and then we go p hat times q hat over n square root. So if you notice, this interval is trying to estimate what? In notation, tell me, what is that interval down below trying to estimate? Good to see you, Noah and Jack and Samantha. What is the interval I just highlighted down low trying to estimate? Which Molly might get it really quickly. What is that interval down low trying to estimate? The interval we just did was trying to estimate the true difference in the means. And the interval down low, the new one I just wrote, is trying to estimate the what? The true proportion. And notice that all you do is write the parameter version of whatever you're talking about. So notice, well, the sample proportion is the estimate, and the true proportion is what we want to understand. So if you went out and talked to, let's say, I don't know, 20 students, and 12 of them love Taco Bell, you would know what? So if you went out and talked to, and I'm gonna bring something up right here, 20 students and 12 of them love Taco Bell, what would you know? Start typing things in the chat to tell me. So remember, I said 20 students talked to, 12 love Taco Bell. So, well, Devin, would we know? Good answers, Devin. Would we know the true proportion yet? And I'm getting some stuff open over here to work on it and show you some stuff. Okay. Great job, Elizabeth. We would know the sample proportion because, and I'm just going to take notes here, we would know x equals 12 because there was 12 successes, and we would know, make it a little smaller, we would know n equals 20, and p hat is equal to x over n. Does that make sense? P hat is x over n. 60% of the sample, nice job, Madison, said it, 60% of the sample love Taco Bell. So if you had to take a guess for the true proportion of people who love Taco Bell, you would use this. Well, we don't have a p-value yet because we haven't done a test. So there's been no statistical test done yet. But we could make confidence intervals. To make a confidence interval, and we'll do it really quickly here, we could do prop test, which actually does the interval, and we just put here x comma n, and it makes it. How would this interval be interpreted right here? Remember, we're talking about Taco Bell. So how would this interval be interpreted right here? And this is really good practice for the last 12 points on the test. How would that interval be interpreted right there? Remember, we're talking about Taco Bell, and if students love Taco Bell, how would that interval be interpreted? I mean, it basically says it almost, but you have to think the context. And remember, MuBot's going to help you out in the chat. MuBot's put a structure for interpreting these in the chat, and we're talking about Taco Bell. So what would it be? MuBot's got some help in the chat. You will be writing these out, especially for the final. I am blank % confident that the true blank is contained in the interval blank to blank. I am 95% confident that the true proportion of students who love Taco Bell is contained. Noah, great job right there. You said it perfectly. And make sure to say true, Samantha. Good work right there. The true meaning for everybody, because we're talking about the population of interest. I am 95% confident the true proportion of students who love Taco Bell is contained in the interval 36% to 80% right there. Perfect. Great job, Molly. And remember, and this is what I want you to be seeing as we do these examples right here, is if you notice that the interval was made from the sample proportion to estimate the true proportion. So we can do the same for the mean. So what we could do is we could take data, like imagine we have right here data on how tall students are. Could Brian have a data set on his computer? Survey 10 Classic. Might Brian have a data set on his computer that would give him the heights of UT students, where he could type height? And these are the heights of UT students. Does that make sense right there? These are, I'm being serious, this is from 2010. These are the heights of UT students. 5'6", 7'2", 7'2". You can even figure out max height down here. Who was the tallest student? We had a student, only 7'6", oh, 6'6", not 7'6". Only 6'6". So, because it's in inches. So now what you would do is you would go here to t.test, and you would just run height. So now be careful, and we'll just round this. I'm going to make the rounded version here. How would this interval be interpreted? So how would this interval be interpreted? So does everyone see down here at the bottom of the screen? And we're doing heights of students. This is your time to practice again. And you can literally see I've rounded it to what I want you to use for numbers, but I'm just having you repeat this to remember this. And I want you to see what's going on right here and the small differences. We're going to pin what Mubot said. These are helping out the last 12 points on the test, where you do have to write out either a test interpretation or a confidence interval interpretation. We'll do test interpretations next. So what do you need to write here? Remember, we're doing heights of UT students. Hey, Sarah, good to see you there. Sarah, amazing tutor. I believe that's Sarah, right? Sarah, the tutor. Amazing job. Hopefully lots of students have been asking for help and getting some great help. How would we interpret this? I think I took a sample of UT students and asked them their heights. We are 95% confident the true mean heights of students will fall, is contained. Intervals contain things. Will fall. Very particular graders might take off for that. I think Pearson might even say it sometimes. Fall puts the active word on the truth. Like if you make an interval, the truth falls inside of it. Contains puts the active word on the interval that you make an interval that might contain the truth. The truth is a value that exists. Very particular graders could take out points for that. I think it's a little too particular, but that's why I say it's contained in the interval. Like I'm 95% confident the truth is contained in the interval. And Sophie, good answer right there. But remember, height is quantitative. And this is what I want to point out, that you won't always say proportion. You won't always say mean. When interpreting the top interval, you will say the true mean. Does everyone see this right here? That the top interval that we just did is interpreted as I am 95% confident the true mean height of UT students is contained in the interval. The next one would be the true difference in means. So you have to see what your interval is trying to estimate. And the last one is the true proportion. So you won't always say the true proportion. A lot of people lose points on the test because they just go straight to true proportion because it's the first one we learned. But the last interval we just did was the true mean. We'll throw you some points right there. Don't worry if you get things wrong. This is practice. But the first interval right here is the true mean, which we just did with heights. The first one we did to start was the true proportion of students who love Taco Bell. But we can also do the true difference in means. So what we could do, and I think there's my razor data set, is I think I can do it right here. If I go to t-test, let me run a question mark in front of it. Might take a half second to run this test this way. Okay, I don't want to do paired. Okay, I should know how to do this. It's easier to actually do inside of, okay. Yes, oh, okay, here we go. I think I can do it. T.test, gender, comma, height. Oh, really? Did get mad? No, did it do it? Something like all duplicated, mad at me. Well, let's do inside a jump here real quick. Will the questions, let me see that question. Will the questions for the difference in means have two means? And the questions, it will. It will talk about the difference of means. And I'm going to pull up, I think I have the same data set inside of here. I'm pulling it up right now. Survey 22. We can use this one. Okay, here we go. Here we are, and here's what the difference of the two means looks like. We'll go right here to gender, and then we'll go to height. And why are there two means for this data set? Wow. Why are there two means for this data set? Explain to me why this is a two sample t-test. This is the theory behind what we're doing. And this is, Molly, the theory of when would we use the difference in means. So what does difference in means mean? And actually a good question, almost like a teaching to the test moment, write it down, that when you are comparing with the two sample means, the two variable types, almost like this is a really good question. What kind of variables are you dealing with when you deal with the two sample T? So click the button in the chat, almost like it's a very good question. What kind of data are you working with when you have two sample t-test? And you can actually see the answer on the screen. And I would look through your test if you get questions like this to confirm the answer. So, and I think a lot of people are getting it. Make sure to write it down. It's not like I give little hints that are very important for the test. But, and Jack is saying the answer right there. We have a mean for males and a mean for females, telling you that this variable down here is categorical and this variable over here is quantitative. Now, a lot of people hear two sample T and they think quantitative. But the two sample T is not quantitative. That is regression. Did everyone hear that? The two sample T is not quantitative. If you're doing the two sample, if you're doing quantitative, you grab quantitative, you are doing regression with scatter plots and you are fitting a line with that huge outlier. That is a QQ straight enough no outliers if I've ever seen one. So with this right here, this is the two sample T. To run the two sample T, we just go here to t-test. So let's run it. It's a two sample T technically. Two sample T because we have a mean for males, mean for females. That's where the two comes from, two means, and we are looking at the one. So what does this value right here on the screen mean? This is a harder one. Help me interpret it. What does that value right there, the 6.4459 mean? 539 mean? What does that mean? What in the world does 6.44539 mean? What does this value mean? Help me understand that value. What in the world does that mean? Remember what we were analyzing? Heights, males and females. So what's that value? Oh, wait a moment. Kind of. It is the difference. Is it the real difference or the what difference? And Samantha said it right there. Great job, Samantha. It is, and very specifically, and Jack's got a great answer there too, it's what we observe for the truth or where. You are right, males on average are 6.44 inches taller, and that's because this is a positive difference associated with the positive, not the negative number. So we have evidence males are taller by 6.44 inches, and this is what was observed in the population or the sample. Adam's on the right track right there. It is a prediction or what we would expect. This is what was observed. Tell me, which one do you think? Population or sample? Is this the population? It is the sample. This is from the sample. This is from the sample. Now I'm going to do something really nice down here. And we're going to call this 6. We're going to call this 7. Does everyone see that those numbers are basically 6 and 7? If you didn't see it, they were basically 6 and 7. And then we're going to call this number right here 6.5. It's going to make all the math a lot nicer. You're going to see in a second. And then we're going to call this number right here okay. So maybe, Samantha, tell me more. I don't see it yet. Maybe, I don't know. Maybe it is. Maybe you see things I don't see. What does this next portion of the output read right here that I'm circling with a blue highlighter? So this is the confidence interval for the difference between the two means. So how do we interpret it? What does that mean? What does that, tell me what it means. Interpret it like it's the test. Interpret it like it's the, pretend this is the test, and your whole test hinges on getting this right. What I've circled in blue, you have to interpret, which I should also mention this goes with it. So that's very important for it. So what in the world? Well, remember, fall, we don't love the fall word. The interval is meant to contain the true small. Good points right there. But remember, use MuBot's format. Right? If you do not have this written down on a sheet of paper, write this down right now. MuBot's got it pinned. He's saying it again. Write this down and know I am blank % confident that the true blank is contained in the interval blank to blank. And don't say blanks, though. Make sure to put the words inside what we say. But notice the hardest part is the second part for people a lot of times. So everything right there, you say the same. I am. You can say we are. I think Pearson says we are. Other notes says we are. I like to say I am. Like I am this confident. We are the royal we. Let's see if anyone wants to take a chance at this and see if they get it. Remember, if you can do it now, it's the measure. Well, this won't be center and spread. I am. And Adam, you're really close. Adam, that would be a lot of points on the test. You just need a little more context. And I think Elizabeth has done it right there. I am 95% confident that the true difference in mean heights of males and females is contained in the interval 6 to 7. And this would be evidence. You might even add a little bit on there. This would be evidence males are taller because the interval is only positive. Does that make sense? I know that's not in the regular interpretation, but because the interval is 6 and 7, which are both positive numbers, doesn't contain 0, there's evidence that males are taller than females. Yes, and really good job right there. And so, yes, Taylor and Elizabeth, I think that would be, if you got points off, you should talk to me for that interpretation. Just make sure, and Adam, great work right there too. Just make sure the context of it is the difference between males and females' heights on average. Great job. And then don't put percentages. You'd be shocked how many people just throw a percentage on that because we're talking inches. So you could also say inches. And great job, Molly, right there. We're throwing you 5,000 points. Just practicing, getting it down, knowing how to say it, so you can get it right on the test. You can always ask me if you think you lost points where you shouldn't. I have given points back. Sometimes I don't. Just depends. So now we get into the big important questions that people were asking. And I'm going to switch what we're notating in the video right here to talking a little bit more about the test. So I need to go over here to the notes. And we've talked a lot about the intervals and their interpretations. But now we're going to talk about t-tests and t-scores. So here's the thing. T-scores are basically z-scores. Did everyone hear that? T-scores are basically z-scores. What is the z-score for a 95% confidence interval? Would we just say 6, 7? We mentioned. Yeah, I mentioned inches. And t-scores are basically z-scores when you have a lot of degrees of freedom. We could talk more about degrees of freedom. Jack, perfect answer. 1.96 or basically what? Devin said basically 2. No, Devin, you're right. It's basically 2. And actually, it's closer to 2 when degrees of freedom are 60 degrees of freedom. It's almost identically 2. And let's just view this for a second right here to understand how the t-distribution works. So the t-distribution has with it what are called degrees of freedom. I like to call them degrees of freedom to be normal because if you notice right here, for a 95% confidence interval, it will, one second. Sneezed into my shoulder. Don't worry, just don't touch my shoulder. I won't touch it either. Watch what happens as I increase the degrees of freedom. Whoa! It's going towards 1.96. And you'd be like, whoa, dude. It's going towards 1.96, man. Wow. You'd actually have to reach how many degrees of freedom for it to be 1.96? For it to be 1.96, you'd have to have how many degrees of freedom? How many degrees of freedom would you have to have for it to be 1.96? Not 1,000. You'd actually have to have infinite degrees of freedom. And the z-score is actually 1.95996. So it's actually a limit. Thank you, Noah. It's a limit as it approaches infinite degrees of freedom. You approach 1.95996. That's because that's the more, everyone says 1.96. But if you go down to more decimals, it's 1.95996. So you add more decimals, and you can see it's 1.95996. But then there's more decimals after that. So if you keep going with your t and give it more and more degrees of freedom, it will keep going towards 1.95996. It'll keep approaching that. Does that make sense? It'll go towards it. But I mean, at some point, it's basically 1.96. And it's basically 2. So with this right here, I want you to think about this. In our output, if we want to make a 95% confidence interval, What would be y bar 1 minus y bar 2? What would be the t-score about for a 95% confidence interval? This is a very good theory question if you get this, so let me put t-scores next. And then what would be the last quantity, which is the standard error of the difference? So s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. So I'm going to erase some highlighting here. Try to find these quantities. What is the difference? What is the t-score for a 95% confidence interval? What is the standard error of the difference? Very important to know this output. Let me call this the 2 sample T output. We'll call that section this. JMP 2 sample T. Wow, Noah, 5,000 points. Noah just said it all. Noah got it because it's 6.5 plus or minus 2 times 0.25. So Noah, what's the margin of error of this interval? Noah, you are correct. What is the margin of error of this interval? So Noah, what is the margin of error? Or anyone else, anyone answer. What is the margin of error of the interval? What is the margin of error? What is it, man? The margin of error is the plus or minus. It's 0.5 exactly. 6.5 plus or minus 0.5. 0.5 is the margin of error. If you see right there, that gets you 6 to 7. Good work. You could just literally do what? How could you get the margin of error without the formula? Can anyone tell me how to get the margin of error of this interval without the formula? How could you get the margin of error without the formula? How could you get the margin of error without the formula? How in the world would you get the margin of error without the formula? Boom, Noah said it again right there. Just take half the length of the interval, upper minus lower divided by 2, because you would say from 6 to 7, you would take half the length, and that'd be 0.5, 0.5, half the length of the interval, upper minus lower divided by 2. Just how far are these numbers apart? Half that distance. Great work, and Julie's great work too. So now here's where you get to people getting stuck on the test. We also have other equations too, like the t ratio, which is not the t star. This t ratio over there is not the t star. That t comes from the complicated t with degrees of freedom, y bar 1 minus y bar 2 over standard error of the difference. So can anyone tell me the mathematics to get this? Find the mathematics for this t ratio right here. What is the mathematics for the t ratio? Oh, that is so not easy to read. What is the math for the t ratio? Which is not the t in blue. Notice I did different colors to them. So it's not the t in blue. That is a t for an interval, which I should have put a star on it, meaning you pick it based on confidence level. So picked based on the confidence. Because 95% confidence is basically a z-score of 2, and then we would let the software do it for us. It's basically using 2. Probably 1.97 or something with 412 degrees of freedom. So I want you to solve for the red number right there. Here's the thing. It's way easier than you think. Way easier than you think. Yeah, Andrew, 5,000 points, and Taylor, you got it. Because here's the thing. It's just the difference, because that's the difference between the two numbers divided by the standard error. And there it is, squeak, squeak, squeak. So you literally just take those numbers and divide them. If you take these numbers right here and divide them, you get the t ratio. Does that make sense? It's called a ratio for a reason. It's your difference in standard error units. So you just divide those numbers. If you look and be like, oh, the difference divided by the standard error is the t ratio. If we blank this out, it's like, oh, you divide those two numbers and there you go, because it's the difference divided by the standard error. The degrees of freedom, here's your trick. What is the way to remember what the formula is for the 2 sample T degrees of freedom? The 2 sample T degrees of freedom formula, what's the trick for it? The 2 sample T degrees of freedom formula, it's what? The 1 sample T is n minus 1. Well, that's the 1 sample T is n minus 1. Good answers, Andrew. The 1 sample t is n minus 1. The 2 sample t is too complicated. It's too complicated. Does that make sense? Good, like mnemonic to remember it. 1 sample t, n minus 1. And we can confirm that by running a 1 sample t. Notice our sample size is 933. So if I were to go here and do an interval for height, so we're just doing an interval for height, because this is just the height of students. And if you go over here, and we were to run I wish it told me the degrees of freedom. We actually have to run a test, it looks like, to have it show degrees of freedom. We'll just test that value, which we will reject. And if you see the degrees of freedom, because there are 933 sample size, the 1 sample t has n minus 1 because we're just looking at the heights of students. Does that make sense? The 1 sample t is n minus 1. The 2 sample t is too complicated. We can show the formula, but it really is too complicated. 2 sample t degrees of freedom formula. That's why we use calculators for it. No one's going to solve it out by hand. I'll grab it, show it right here, copy image, and you can see the dope. Here is the too complicated formula that we are not solving out by hand. It's too complicated right there. We're not going to do that by hand. So the last bits of the output, let's look at the last bits of the output right here. With the last bits, these are all the whats. Oh, we would never have you work that on the test. The questions like I ask are very similar to the test a lot of times. The last bit of the output, and good morning, Elizabeth. The last bit of the output is what? We've done a lot right here, but what's this last bit of the output right there that I'm question marking? It's the p-values. And why are there 3 p-values? Because there's 3 alternatives. This is the does not equals. This is the greater than. Notice how it's greater than right there. And this is the less than. Notice how it's less than right there, not less than or equals to. Now, how do you pick? How do you pick which p-value to use, which sign to use? I'm going to sing the whole class. How do you pick? How do you know which one of these 3 you're going to use? You've got a does not equals test. Do you look at the data or the researcher's question? Will the data decide? Well, it is going to do the way we graph the graph, left, right, or both sides, is determined by the sign of the alternative. And the researcher's question is how we pick which way we shade the graph. Are they looking for a difference? Does not equals. Are they looking to see if things have increased? Greater than. Are we looking for if things have decreased? Less than. What's really interesting, and I might have to redo this output because we've drawn so much on it, is you can see, and it's kind of obvious, if you go to the one that we have evidence for, we have evidence that men are greater than women. Mu male greater than mu female. All you have to do is input this value in right here. We will start the Kahoot very soon, but we have evidence. So let's say that researchers wanted to look at if males are taller than females, and they used an alpha of 0.02. So, hey, Jana, good to see you here. Let me throw you some points, Jana. Throw you a little puppet shark too. Thank you for being here. We'll start Kahoot very soon. Glad to have you here. So I want you right now. Good to see you, Noel. We'll be starting the Kahoot soon. So try this right now. And Andrew, good to see you too. Try interpreting the test. We write out a lot of things here. We practice it all. So go ahead and pretend this is the test that was run to see if to see if males are taller than females. So you can see Mubot's put in the chat right now. Mubot, our trusted bot, has put in the chat an interpretation for us. And you notice you need to select, it's like pick choice 1 or choice 2 as you do this. And I'd highly suggest writing this down, putting it on your door, saying it out loud. I reject or do not reject a null, that, and then state your null, because my p-value of this is less than or greater than blank. That's your alpha level. This means I do or do not have evidence for my alternative that blank. And correct Noel. Noel said the p-value is 0.00001. And how do you know if it's two-sided or one-sided? This is a one-sided test because we are only testing for our males taller than females. The null hypothesis was that males and females have equal heights. And a good thing to remember is the null always has the equal sign when we write it out mathematically. So the null, I do have it written second. The null hypothesis is that the true mean height of males is equal to the true mean height of females. The alternative that we are looking for evidence for is that the true mean height of males is greater than the true mean height of females. So give it a shot right here. See if you can interpret it. MuBot's got the interpretations. And Molly's question again, how do we know if it's one-sided or two-sided? As in tailed, we call those the tails. The one-sided or two-sided, one-sided is going to be these for less than or greater than. You either shade to the left or to the right. And two-sided is the does not equals. You know it's one-sided when the researcher says, let's see if males are taller than females. Let's see if females are taller than males. Let's see if things have increased. Let's see if things have decreased. Those indicate one direction, the band. And then you know it's two-sided when they say things like, let's see if it's changed. Let's see if they're not the same. Because not the same or changed means any sort of difference. So the two-tailed means any sort of difference is being looked to be detected. Let's see what Noah has right here. I reject the null that males and females are the same height on average because my p-value of 0.00001 is less than my alpha of, don't worry, not a big deal. No, I put a 0.02 alpha, classic 0.05 alpha. You just put that in your receive out, catch it, 5,000 points, Noah. This means I do have evidence for my alternative that males are taller than females. Noah, great work. If they took off more than half a point on that, I would be very angry, maybe a quarter point at most, because you went for classic alpha. The question might dictate to you the researcher's alpha, and just make sure to use whatever the researcher states their alpha is. So researchers might pick their alpha, but Noah did the right thing of using 0.05 unless otherwise stated, which is the assumed alpha that pretty much everybody uses. But alpha is something up to the researcher's opinion based on when they want to reject the null and have a certain type 1 error rate. I reject the null that males and females on average, so Devin, good answer. I reject the null that males and females are the same height or have the same average height because my p-value of 0.00, throw an extra 0 on there, is less than 0.02, maybe call it your alpha 2, good answers. This means I do have an alternative that males are taller than females. And you can say there isn't sufficient evidence when you fail to reject the null. Andrew, great answers. There's lots of ways to phrase this, and so that would be a good way too. If you fail to reject the null, you do not have sufficient evidence. And that's why I like to say if you do not reject the null, you do not have enough evidence. Not having enough evidence would be not sufficient evidence. This means I and Noel wrote, and we're going to start the Kahoot in about 2 minutes. This is the last bit of this output right here. I reject the null that males and females are on average the same height because my p-value of 0.001 is less than my alpha of 0.02. This means I do have evidence for an alternative that males are taller than females on average. And that makes sense, right? Would we fail to reject the null if we did less than? When we'll do one last thing right here. Are we going to go over power? Ooh, and 1 minus beta? We can do that. So we have a famous saying, and we'll end with our famous saying. I might do 5 more minutes and then do the Kahoot. And thank you, everyone. I don't know how many people are here yet, but we had a bunch of people responding. I love it. So let's do famous sayings to remember. Okay, we're going to do famous sayings to remember for the test. So Braden, you came in at the perfect time. Here's some of our famous sayings in the class. I want you to finish them, to start typing them in the chat. Good morning, Andrew. I want you to finish these in the chat. See if you remember them. All right. When the p-value is low, oh man, Taylor's got the full thing right there. When the p-value is low, reject the null. When the p-value is high, just let it fly. When the p-value is low, reject the null. When the p-value is high, just let it fly. And what do we mean by this? Great job right there, Molly, also. When the p-value is lower than alpha, Taylor wrote some good stuff there. P-value low means the probability of your results more extreme by random chance variation given the null is true. It just means you saw something unlikely given what you expected. So you reject that thing you expected because what you saw was not likely. When the p-value is high, just let it fly. That means just let the null be. Do not reject the null. And I always like to say, do not reject the null, but we have to teach you fail to reject because everyone says fail to reject. Do not reject is the same thing as saying I failed to go to the mall. I did not go to the mall. I didn't go to the mall yesterday. I failed to go to the mall. And so we just don't talk like that much anymore, but people still say it when they write research or do it. So I just say I didn't reject the null. Like if I'm talking to someone, I'll be like, yeah, we didn't reject the null. Failed to reject. Do not say what bad words. Someone put some, if you know our bad words in this class, put them in, you know what I'm talking about. Don't put real stuff. There are real bad words in this class. So we have words we don't say in this class. Yeah, Parker knows. Parker, we don't accept the null. We don't accept the null. If you see accept on there, prove or things, Mubot's getting angry right there. Mubot's mad in the chat. So yeah, he's making Mubot angry right there. In a type 1 error, the null is true and we reject it. Yeah, if you say cause, Mubot should really get mad about that. Just type cause by itself. Nice job, Taylor. Mubot will get really mad if you say cause. He doesn't like that word at all. Type 2 error, the null is false and we fail to reject it. If you just type cause, he'll call you out if you say cause. I'm gonna go over here for this last part. Okay. So here's how to memorize it. What number is this? Start spamming it in the chat. What number is this? What number is this? Low p-value is lower than alpha, Andrew. Good question. Low p-value lower than alpha. 1. What letter is this? What letter am I making right now? For those in class, they know exactly what I'm about to say. What letter is this? T. In a type 1 error, the null is true and we reject it. So you can remember type 1 error, the null is true and we reject it. What number is this? We'll go quickly on this because people know. What number is this? Noel will be reviewing that. 2. And what letter is this? What letter is this? Decode what my fingers are making with letters. You have to think like this and this. Because I've had people say, what are you talking about? F. Great job right there. In a type 2 error, the null is false and we fail to reject it. In a type 2 error, the null is false and we fail to reject it. It's kind of cool because you go a type 2 error, the null is false and we fail to reject it. How many F's do I say in the type 2 error? So when I say in a type 2 error, the null is false and we fail to reject it. How many F's do I say in the type 2? I say 2 F's. It's a good way to memorize it, and they have to think about what it means and what it means to have a type 2 error, which is a false negative. Type 1's a false positive. But to learn it at first with memorization is a good way to get it down. In a type 1 error, the null is true and we reject it. In a type 2 error, the null is false and we fail to reject it. So with that, let's get Kahoot going. What questions are there? I'm going to play one of my favorite songs right here. What questions are there as I get the Kahoot going in the background? We have Kahoot t-shirts. Frankly, if you want one, swing by my office when I'm here. You might need to come next semester. Spy example, false negatives. That's really cool. You need to tell me that example with the spy. Probably about like catching the spy with the false negatives. That'd be letting the spy go. Because you need evidence someone is a spy. So a false negative would be the spy is hanging out in your midst, spying about. But a false positive is like, you're a spy and I'm like, what? And I'm not a spy because you had a false positive. Thank you, Jana, right there. It's actually Hannah, a former student worker who came up with that while she was taking Stats 101. She was like, Brian, I got this great idea. In a type 1 error, the null is true and we reject it. In a type 2 error, the null is false and we fail to reject it. And actually, it was this semester someone added the extra 2 at the end because they're like, isn't there another 2? And I was like, wow. So, or I was more like, wow. So it's really the just whole of knowledge that comes over time, and that's helped me remember it. So if you have questions or comments, we're getting the review going right now. I will say this, Moira has her review after that. I think at 2, Moira's gonna have her review. I think it's in strong, so please, if you want, go to Moira's review. It'll be today, Moira's review. And Moira is a pro. I think she's our lead SI or gonna be our lead SI. So if you wanna learn from someone who is a genius, I'm gonna say that, Moira, you're a genius. Moira from 2 to 4:30, and I recommend, go to all the reviews you can, ask questions, take notes, do the examples. Moira's also got a, we're gonna try to finish up before Moira's review, so go down there, especially if you're on campus, just go down there. Maybe I'll even swing by. Maybe I'll swing by and say hey, and be like, hey everybody. Then I'll be like, good work. So she's made her own practice test YouTube. I think she does record them, I think. So I hope, and if you can attend, don't worry if you can't attend in person, life's busy, campus is crazy, but if you can, do it. If you can't, I hope it's recorded. With that, Moira's review, B1, 2 to 4:30, but you know what time it is. I need a little I'm ready in the chat. Where's my I'm ready? So we're about to Kahoot, and I hope we got a lot of people here. We used to have like 300 students Kahooting. I had to buy a more expensive Kahoot account. Sarah's ready. Andrew's ready, Taylor's ready, Kaylin's ready, and I'm ready. Okay, here we are. I think we might be doing some tomorrow. I'll send out announcements about that. It's been a hectic week. But we are waiting for players. And so join on in. Let the fun begin. Giving Tiger, you're looking cool there. Green Frog. Oh, you look sad when I hover over you. It's because you think I'm going to remove you. It's so funny. I won't remove you. We have how many people watching right now? Let me see Mubot. Let me ask Mubot. About how many people are watching?
Thank you, Brian. Let's see how many people are watching. Where is Mubot? There are 47 people watching, so Brian, you should have at least 40 people playing Kahoot. This is Mubot. You didn't see that. Mubot, away.
Well, thank you, Mubot. Very kind of you. 36 people playing. It's always, you see, the problem is I can get a lot more people playing if I do this the day of the test. Maybe I will. Maybe we'll, don't call me about redo the Kahoot the day of the test, and people will, like, we'll get 300 people playing then. But more people watch it in the review. Like, people will use it to review, but playing along is the real way to learn. So while you're playing, here's the thing. A lot of people quit out. If you can play the whole time, please do. If you're getting things wrong, that's the reason to stay. If you're winning, quit. You know it. You're spending extra time studying. So if you're winning, quit. Don't quit. But do you see what I'm saying? Is a lot of times people start missing questions and then they quit and they say whatever. But if you're missing questions, you're seeing things you need to learn. That is the most valuable things for you. That is the most. You're getting just knowledge after knowledge. You might make a 40 without this Kahoot, and with this Kahoot, you make a 65. But the person who's at a 95 knowledge right now, they could only go up to 100. And I want them to be here. I want everyone to be here. But if you are missing questions, shout outs to you for being here. 5,000 points. We'll do a little Wacky Wednesday on that. Where's my Wacky Wednesday? Be here. Okay, it is time. We are about to Kahoot. Here we go. In 3, 2, 1. First question is, how would we test to see if there's a relationship between being married and non-married students? What would we do? These are known as the tools and techniques questions. So what you want to do is, if you get a tools and techniques question, is you want to figure out what you've learned in the class and how it applies. So let's start first with the chi-squared test of independence, which is the last chapter we did. If you've already answered, please reply in the chat. When do we use the chi-squared test of independence? When do we use the chi-squared test of independence? When what? When do we use the chi-squared test of independence? Does anyone know? When we have two categorical variables. That is very important right there. Do you have two categorical variables? You do not. That's known as count data, so we don't have that. When do we use the one sample T? When we have one mean. When do we use the one proportion Z? When we have one categorical variable. The two sample T is used to compare the what between two means. The two sample T is used to compare the what between two means. The two sample T is used to compare the difference between two means. We could do gender and height. This one is married and non-married and is comparing the differences in their whats. This one is married and non-married and it's comparing the differences in their whats. That's weird. Pep Boys called me or something. Difference in their age, exactly. So, do you know my name? Yeah, if that's I got a thing from Pep Boys saying, oh, he said Derek, so he doesn't know who I am. What was the Z one used for again? The one proportion Z is used to look at a proportion, like the proportion of students who love Taco Bell. So this would be looked at the proportion of students who love Taco Bell. This would compare the difference between two quantitative groups, or difference between two groups on a quantitative measure, like comparing the age of married and non-married students. This would just look at the age of students. It doesn't compare groups. Does that make sense? What a one sample T does, it only looks at a quantitative variable because it's just, let's analyze a quantitative variable. What's another saying we have about Mr. T? What's another saying we have about Mr. T, especially if you're doing drugs? What's another saying about Mr. T? What's another saying about, he's right here. This is Mr. T if you're doing drugs. Watch out. Watch this glass right there. Watch that glass. You ready? That's what happens when you use the wrong distribution. Mr. T is mean if you're doing drugs. Now, why do we say Mr. T is mean if you're doing drugs? Because I don't want to disparage his name. Because the T-test is used for quantitative measures. Go back to the notes we had before this, and you'll see the T is always used for means. The T is used for means. So these are little mnemonics we come up with to memorize things, that Mr. T is mean if you're doing drugs because it's used for a quantitative measure for means. Let's look at that leaderboard. Devin, great job right there. We got Elated Badger, Mighty Lobster, Jolly Wolf, and Silly Swan and Giving Lizard. Next question. Here we go. How can we test a relationship between someone owning a pet and if they are married? Remember, we dropped some hints for this a moment ago. How can we test the relationship between someone owning a pet and if they are married? These are called the tools and techniques questions, which ask you, what would you use here? And the best thing to do a lot of times is look at the variables you have. Now, there could be things like the multiplication rule, like how would we test to see if you would win 6 times in a row buying lottery tickets? How would we test to see if you if it's going to be raining in Knoxville and raining in New Zealand at the same time? Multiplication rule requires things are independent from early semester. Remember that. So there are things outside of what I've asked here, but these are the questions. So let's look. The two sample T is comparing two means. We just did that for the last one. This is not two means. What condition would be passed by having people who are married and people owning a pet? What condition requires two categorical variables? Do you remember what the condition's called? What condition is there where there has to be two categorical variables? Great job. Not independent. Good. It's not independence. That's between two means. Counted data. Yes, Jana right there. Another points in the chat. And good work, good practice. It is count data, which is a condition for the chi-squared test of independence. Noah, the other one is expected cell count. The conditions for the chi-squared test of independence are, I'm going to type them in the chat for you right here, random 10%, and then we get to expected cell count, and then we get to count data. I do want to point out right here a very important review because we're going to lose people as we go through. But if you want to review the conditions, go to my review video on the conditions for exam 3. Mubot just dropped the link in the chat and you can click it and break your screen. But here on this video right here, I write out all the conditions and you can see them. So Jana, great work. You went straight to count data, which states for the chi-squared test of independence was chi-squared test of independence with two categorical variables, it has to be count data, which is literally passed by being two categorical variables. You can also see here that two sample T has two means, and it has a quantitative Y, but a categorical X, which we saw earlier. One proportion is just a categorical variable, and the T-test is one mean. You can see all the conditions right here, screenshot it or watch the videos. Link is currently pinned in the chat for you to check that out. So let's head back over here to the Kahoot and see who's in the lead. Next question. Nice job, Avante. Avante, that's going to become the pinned message. Avante, that's a really good mnemonic for remembering it. Avante said, C chi-squared, count data, categoric. Wow, all the C's with chi. Avante, I'm just making Avante a mod out of that. That isn't earning a mod. I'm taking a risk. I don't usually mod people during these, usually wait for class, but Avante, that is one of the best comments I've seen in a while and a good memorization mnemonic right there. Good work, Avante. When doing a hypothesis test on the mean, which is a condition that must be true? So we just saw the conditions. Rewind the video, which you can do live. If you don't know, you can rewind live and see the conditions when testing a mean or doing a confidence interval on the mean. All those W's for Avante in the chat. So when testing the mean or doing a confidence interval on the mean, you just saw the conditions. So if you're stuck, you can rewind live. Now, we always have a saying here. Condition 1, random. Condition 2, 10%. And then what do you do before saying condition 3? You know it. You're going to put them in the chat. What do you do before going to condition 3? You pause. Because you have to think, what kind of data am I working with? And we'll see it here on the screen in a moment. But the third condition could be success failure, which states we need at least 10 successes, at least 10 failures. And that's for categorical data. The third condition could be nearly normal, which states the distribution of the quantitative variable needs to be approximately normal, checked by a lot of ways. Or it could be expected cell count at least 5 for chi-squared. And the answer to this one is nearly normal. Great job. We got all this pause in the chat. The reason we say pause here is because I'm from New York, and also the first two conditions are the same. Now, there's really no order to the conditions. I just like if you put them in this order, you can always say random 10% and then pick your third condition based on what you're doing. Additionally, random means we randomly selected the individuals, and 10% means we took less than 10% of the population. Remember, if you have any questions about any of these, please ask. I will cover these and show you resources as we do the review, but feel free to say, well, wait, what does this mean? How'd you know this? Why would we do that? But very good responses here. That's 80% got it. Good work. And the expected cell count was the next highest, which is for chi-squared. Success failure is for proportions like testing what percent of people love Taco Bell, or expected cell count for married versus non-married and owning a pet for testing that to see if they're independent. Here we go with the leaderboard: Giving Lizard, Inspired Lobster, Elated Badger, Groovy Finch, and Mighty Lobster. Next question. Which condition do we need at least 5 of? So in one of the conditions, we need at least 5 of something. And if you can also write out the formula for this condition, that'd be good, and I'll throw some points in the chat. So what is the formula for this condition? And I think you can see all the answers on your phone. So I'm going to go draw a grid for it. Oh, no, Devin, it's all right. I'm going to take a poll moment after I do it this way. Kind of. Yes, nice. Caitlin got it. Yes, great job. Jaina also, good work. Jaina's a, you know what, let's just make Jaina a mod too. Great job, Jaina. W for Jaina's in the chat. Great job, Jaina. Okay. So the answer is, I think it went through. The answer is expected cell counts is where we need at least 5 expected cell count. And so with this writer, I want you to think. We have if somebody is honors or not. So this is honors student. And we have yes and we have no. And we have did they make an A or not an A? Does that make sense? We have 100 students made an A, 100 students didn't make an A. So did they make an A on the test? And so we have 80 honors students in the class. And if I were to ask you this, how many honors students would you expect to make an A? The answer is actually really easy. How many honors students would you expect to make an A? See if you can solve that right now, and I will probably even show jump output for doing this. So how many honors students would you expect to make an A? See if you can get it, and then we'll do jump output on this. This is how to get expected cell count. The formula is row total times column total over grand total, which is N, capital N. It is 40. But here's the thing of this. Half my students made an A, right? So you can show the math too if you want. If someone shows the math, I'll pin the math. But if half my students made an A, and there's no relationship here, wouldn't I expect half the honors students to make A's and half to not make A's, half of these to make A's and half of these not to make A's? That looks to be correct, Noel. Great job, Noel. So the formula is row total times column total over grand total. 80 times 100 over 200 equals 40. And what you do is you circle the ones. We have honors students making an A, and you just do this. So does that make sense? Row total times column total over grand total. You zoom in on it. So you say, let me just go boop, boop like that, and crosshair in on it, and you can get it. I'm going to show how to do it in jump right here and how your jump output might look. I'll do the same sort of work. And so I have to quickly make the data. Let's say honors. So this is honors, yes, yes, no, no. And this is making an A. Made A. Wait, no, wait, we'll say A. Oh, sure. This is A, not A. A, not A. There we go. And then we have to have the frequency. Can you show it manually for not A? Yeah, I think we can. We'll do a few of these right here. This is not what you guys are doing. I'm just doing it quickly. Honor students, 60 here, 20 here. And then anything else all math. I have 120 left. So I need, how many people made A's? I think that's right. And then the 80. Okay, I think this did it. Analyze fit Y by X. Does honors explain making an A with the frequency? So you're going to see jump output now like you would on the test. And we have done it. It's in different spots. Does everyone see this is the same output you saw a moment ago? Does everyone understand? It is, the table is built a little bit differently. But does everyone understand this is the same output you saw a moment ago? How are we doing on that? Just I want to know if you understand that. You can see the 100 students made an A, 100 students did not make an A, 80 students are honors, 120 are not honors. I think that was the same way we... Ooh, it's not exactly the same. 2 seconds. Let me remake the output. Honors... No, that's right. 80 students were honors, right? Yeah, I think that's it. Well, I did it. Sorry about that. I thought I made a mistake. I didn't. Honors there. And actually, we can make it the same by doing this. I prefer it the other way, but that's fine. Okay. And now it should be the same exact. There's the hundreds, and there's the 120s, and there's the... So everything's the same. What we usually do in jump is we give the expecteds and the cell chi-squareds. And now you can see it right here. And let's bring this over and show what you would see on a test. On the test, we usually blank out values. The first value I'm blanking out is a what value. That first value I've blanked out is a what value. Yeah, exactly. That's what I did over here, Caitlin. Good question / answer. I blanked out an expected value because it's the second one. The next value I'm blanking out down here is a cell chi-squared, because you can see by the order in which they go in the same order here. So you just look at the first, the second, the third, the first, the second, the third, and those are the values in that order, which you're seeing. So since this is an expected value, the expected value formula is row total times column total over grand total. Does that make sense? And that's the same formula we just did a second ago. So you'd write 80 times 100 over 200 equals 40. And you can just solve it out and you get that. The next one down here, how would we solve this other blanked out formula? These are really good questions. Like the test literally does this. What is the formula for a cell chi-squared? What is the formula for this cell chi-squared? A cell chi-squared, which is on your formula sheet, is what? I'm writing it out, basically. Great job, Nara, right there. And please tell me if I mispronounced anyone's name. Narav, right there. You are correct. Observed minus expected squared over expected. Observed, and I write O minus E over... and squared, Noel, squared. Observed minus expected squared over expected. And with this, the observed is the what in this output. Where is the observed over here? What value is the observed? Observed is what you see. How many you count? Where's the observed? Because you have to know how to use the output. It's the first row, it's the count. And so where's the expected? Well, it's the second value right there. There's the expected. And there you just plug in the numbers. You just go 20 minus 40 squared is 400 over 40. There it is, 400 over 40. What's 400 over 40? 10. Decimal differences. There you go. That's how it's done. Last question on this. How do we get the chi-squared test statistic? And for 5,000 points, what is it? How do we get the chi-squared test statistic? And for 5,000 points, what is it? The chi-squared test statistic is found by the what of the whats. Add up all the cell chi-squareds. So what is it? Not too hard to find. So you have to take all the cell chi-squareds. You just add up all the cell chi-squareds. So what is it? What is the chi-squared test statistic? Everyone's right. Great answers, everyone. So what is it? You just add them all up. Not that much to add up. I did it. 33.33, I think. 30. Great job, Devin got it. Yeah, exactly. And everyone's carrying the last decimals. Great job. So it's 33.33. And I said last question, but last question. How many degrees of freedom does this have? So you have to say, Brian, this is a 2 by 2 because it only has 2 answers to each thing. You don't count the totals. So how many degrees of freedom are there? Brian, this is a 2 by 2. Drop 1, 1 degree of freedom. So if you're memorizing this formula, it's rows and columns minus 1 times together. And Noah's saying it. So it's a 2 by 2, 1 times 1. So there's 1 degree of freedom. You bet this is statistically significant. You would not need to find that test, but there is the Pearson chi-squared test statistic right there. You can see 33.333, p-value well below 0.05. And we would say, I reject the null that being an honor student is independent of making A. We have evidence that being an honor student has a relationship to making an A. Doesn't mean it causes it, it's just related. Because my p-value of 0.001 is way less than my p-value of 0.05. Okay, let's look at the leaderboard. That was a big review right there on the chi-square test of independence. Inspired Lobster, Elated Badger, Groovy Finch, Mighty Lobster, and Charming Chicken. Great job. Which of the following must be met for the chi-square test of independence? Go ahead and tell me. Which of the following must be met for the chi-square test of independence? Be quick. Great job, Adam. So Noelle's maybe wondering, how did you know it was significant so quickly? Large chi-squares indicate smaller p-values. And I have an idea of when a chi-squared is large, you would not need to have. I've just looked at so much data that I think chi-squared with 1 degree of freedom is significant after about 5 or 6, definitely after 8. But larger chi-squareds are smaller p-values because the chi-squared is larger when there's bigger differences. Bigger differences are evidence of the two variables being not independent. So bigger chi-squareds lead to lower p-values or calculate lower p-values. Great job, Devin. Devin knows there's 2 answers to this question. Expected cell count greater than or equal to 5. And don't worry if it's exactly 5. We won't do that on the test. And the count data condition, which states we need to have 2 categorical variables. So a lot of condition review right here. Great job. Nearly normal is only for quantitative data, the 1 sample mean or the 2 sample mean. And success failure is only for categorical data. We need at least 10 successes, at least 10 failures. Okay, let me ask one quick question. If I were to test class level at UT and 3 living locations, how many degrees of freedom would there be? So we say someone either lives on campus, off campus, or out of state versus freshman, sophomore, junior, senior. How many degrees of freedom would this test have? So it's just kind of another review question. Molly did it instantaneously, just like that. Boom. It's that easy. Does everyone see with this having 4, freshman, sophomore, junior, senior, this having 3 on campus, off campus, out of state, which is I know it's a subset of off campus, but it's still a different thing than off campus. Then you would just drop and multiply. So all you do is you just take rows minus 1 times columns minus 1. There's the answer. 3 times 2 is 6. Good practice, Eleanor. Great job right there. Leaderboard time. Inspired Lobster, Elated Badger, Groovy Finch, Mighty Lobster, and Charming Chicken. Next question. Let's do this. The chi-squared test of independence statistic. The chi-squared test statistic is found how? And which of these is it in here? Which one of these? You can tell me what the chi-squared test statistic is. A test question might ask that. Maybe there's a test question that asks you, what is the chi-squared test statistic and what is its p-value? So what is, boom, it is the Pearson, which is this. A good way to memorize that is that you go to my Pearson for your work, which is a famous mathematician, and the Pearson chi-squared test statistic is just his way that he found it. The Pearson chi-squared test statistic, and its value is 0.338. So the Pearson chi-squared test statistic. So what is the p-value of the Pearson chi-squared test statistic? What is the p-value of the Pearson chi-squared test statistic? What is the p? You can just type in the chat. It's not on here right now. I mean, the question. So it is that. Great job. And I know, right, Narav, you've been in multiple chats. We're going out on limbs today. Narav, you're also a mod. Thank you. Good. I'm glad you're here. To give some W's in the chat really quickly for Narav right there. And good work, everyone in the chat, with the answers right here, summing all the cell chi-squareds. And I want you to notice something. Who's noticed that we are in Kenai? Good to see you, Kenai, again. Who's noticed that we repeat a lot of these things? We were mentioning it earlier, that the chi-squared test statistic is found by summing all the cell chi-squareds. You'll hear me repeat a lot of things and practice it because I know it's on the test and I want to make sure you see the sum of the cell chi-squareds is the Pearson chi-squared test statistic. So if you look at this value of 33.33 right there, That value of 33.33333 is obtained by 6.6667. And if there's 1 degree of freedom, will both chi-squareds be the same? No, good question, Caitlin. Good theoretical question. The likelihood ratio is just a different test. I wish I knew more on it. I read on it one time and then I forgot, and I never use it. So if you don't use it, you lose it. So it's just another way of doing the test, which has different assumptions and can be used for different things. And statisticians sometimes use it. I don't. It's like, imagine you have 2 ways you drive to work. As long as you have 1 way that works, so you're good. This is my way of driving to work, the Pearson chi-square test statistic. It's just, we have a lot of tests and stats. I know a lot of them, but not all of them. And I do want to say this, though. Think about this. When the chi-squared is large, the p-value will be water. Yeah, it was happenstance. Good questions. Let me throw some points for that. When the chi-squared is large, the p-value is often water. Smaller. When the chi-squared is small, the p-value will often be water. When the chi-squared is small, you don't have to worry about what small is. It just works that smaller chi-squareds often lead to larger p-values. Do you see that? What is the smallest the chi-squared can be? What is the smallest the chi-squared can be? Because you're summing up differences. So, no, they're differences. They are inversely related. Great job, Elizabeth, right there. They are inversely related. So what is the smallest the chi-squared can be? The smallest the chi-squared can be is what? The smallest possible value of chi-squared is what? 0, where there's no differences. And if you have a chi-squared of 0, you'd have a p-value of what? If you have a chi-squared of 0, you would have a p-value of what? Of 1. Now notice as the chi-squared gets bigger, the p-value is getting water. Do you see it? We'll start again at 0. But as the chi-squared gets bigger, the p-value, and I should have done more decimals so you could see it here from the start. The p-value gets smaller. It's less area to the right. Chi-squared is always a right-tailed test because we're looking at differences and the differences are squared. So it's a squared distribution. So it's a right-tailed test. And they're dependent. Well, they're kind of dependent because, yeah, the chi-squared finds the p-value. We call it the chi-squared test statistic because we use the test statistic to find the p-value. So really good review right there. Make sure you please check out the review videos. I hope people have been using these. You even get the epic speed runs right here with the really fun intros. You can go listen to the music. Epic, 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 epic Stat 201 speedruns of statistics. Brian Stevens. It's him. Versus Chapter 17 or 14, whatever we're doing. So check out the speedrun reviews. They can be found right here on the test page. Mubot is going to drop it in. Watch them, listen to them, practice them. Let's go back to the Kahoot. It's like an advertisement midway through. It's the mid-roll. Okay, we've got Inspired Lobster, Elated Badger, Groovy Finch, Silly Swan, and Inspired Iguana. All the inspired here in the chat. What is your decision regarding the null? Be very careful. How many of these answers can you instantly eliminate? So once you've answered, feel free to talk to me in the chat. I'll just keep reviewing with you. How many of these answers can you instantly eliminate? 2 of them. We have bad words in this class. We don't like the word accept. We either say, I reject, or I do not reject. Do not reject is the same thing as saying fail to reject. It's like saying I failed to go to the mall yesterday. Well then, I did not go to the mall. Exactly. We don't say accept in this class because accept means like something is true. It means you're no longer questioning it. Question everything. Skepticism in good ways. Don't be like, do I exist? I mean, you could take a philosophy class for that one. But reject are the good words right here in Andrew. So we like to say I reject the null or I do not reject the null. So when do we reject the null? Now, someone could go really crazy and say, what if I use an alpha of 0.08? Don't 0.8. Don't do that. We reject the null when the what is what. We reject the null when the what is what. When do we reject the null? Oh, wait, here it is. Oh, we failed to reject because it was high. We reject the null when the p-value is low. When the p-value is low. So the p-value is high, so let the null be. Just don't reject it. So since the p-value is high, just let the null fly. And good work. Only one person put accept. Don't worry if you put that. Just remember, don't put accept. It'll make us sad right here. Ubot will get mad in the chat if we put the word accept. Reject the null when the p-value is low. And you can say small, works for you, but I like the rhyme of it. Like when the p-value is low, reject the null. It doesn't rhyme, but it kind of, I don't know. Mutebots came at me again. Are we assuming alpha 0.05 unless otherwise stated? Always assume 0.05. Why is the answer fail or reject? Who can write a quick sentence? Noel, good question right there. Who can write a quick sentence on why the answer is fail or reject? With the assumed alpha level of 0.05, who can write a very quick sentence? And Adam, good work right there. Yeah, and Andrew, good work. When the p-value, you know what? Just doing it. Why not? I don't think anything too crazy can happen. Andrew, welcome to the mod squad. So the p-value here, and it's based on the data exactly, the p-value here is greater. P-value was 0.56, which is greater than our alpha level of 0.05. Boom, Jack. Great work, Jack. Good answers. The p-value of 0.56 is greater than our alpha level of 0.05, which is assumed without any other alpha level given. So great job, Jack. And W. Andrew in the chat right there. The fail to reject throws me off, so I always have to pause and think about it for a moment. Yeah, just... And truthfully, here's outside of this class, just tell people don't reject. So we can start this movement where people say, I don't reject the null. I should literally make a video called like, we need to start saying I don't reject the null. All textbooks should be changed to I don't reject. No one should say fail to reject. You either reject or you don't reject. It's dichotomous. And that's what fail to reject means. When the p-value is higher than alpha, just let it fly. Exactly. Pearson p-value. The Pearson has your p-value. Nice job, Andrew. I've said that too. The Pearson has your p-value. Because the Pearson chi-squared test statistic, that's the chi-squared test statistic, the sum of all the cell chi-squareds, and that is the Pearson p-value, or the p-value of your test, and that's the degrees of freedom you had, and that was your sample size. Everything else in this output doesn't matter. Literally the only things in this output you will be tested on, I'll highlight it here to show you once again, the only things in this output you could possibly be tested on would be sample size, which we probably won't mention, degrees of freedom, which is the shape of the chi-squared, the sum of the cell chi-squareds is the chi-squared test statistic, and this right here, the p-value of your test. Those are the only 4 things that come from this output of note for the test. Leaderboard time! Inspired Lobster, Elated Badger, Groovy Finch, Silly Swan, and Fast Goat, fastly jumping up the leaderboard right there. Next question. How many degrees of freedom does this test have? I know you can get it. Shouldn't be too hard. It is a 2x2. We are testing gender, and if anyone's broken a bone. We are testing gender, and if you've broken a bone. While we're talking about this right here, I'd like for you to put the null hypothesis in the chat, which might be a coming up question. With the chi-squared test of independence, there's a really easy way to remember the null hypothesis. With the chi-squared test of independence, what is the easy way to remember the null hypothesis? It's called the chi-squared test of independence. So to write the null, you just do what? Well, so be careful. Elizabeth, really close. Elizabeth, great answers. Remember, the null is that they're independent. Great job, Caitlin. The null is that they're independent, not related. So the null, you just put the word at the end or between them. You just say, gender and breaking a bone are independent. And then the alternative is that they are what? So remember, this is the chi-squared test of independence when you have 2 categorical variables. The null would be, someone's gender and breaking a bone are independent. The alternative would be what? The alternative would be what? To do the alternative, you just write not independent. So this is the alternative, not independent, and the null is independent. So you just add in the extra word, not independent, or you add in not. Gender and breaking a bone are not independent. So what does it mean to say gender and breaking a bone are not independent? Like, I don't know what this independent stuff means. You can kind of say dependent. I'd be fine with that. So let the graders know if they take off points. I'm okay with that. Pearson gets a little mad sometimes. Associate. What does it mean associated? I mean, do you see an association here? Do you see an association in this data? Do you see any sort of association with breaking a bone and gender? Does it look like there's an association? And what is that association? Meaning they're not independent. Look at the data. Well, the p-value is low, which means we reject the null and we have evidence for alternative. And what does it look like is the association? How would you talk to me about it? So look at the data and what does it show? What does this mean? What's going on? Well, that's the females who have not broken a bone. This is the males who have not broken a bone. That's the males who have broken a bone. So, and what are we learning visually? Avante, good answers. What are we learning visually from this? That it looks like there's evidence. What? It looks like there's evidence. What? Kylie, great answer. It doesn't mean females don't break bones. It just means males are more likely to break bones. So it looks like there's evidence that males are more likely to break bones. It could be, but here's the thing: there can be confounding variables or lurking variables like contact sports. So it might just be contact sports, and then because males are sometimes more likely to play contact sports, actually, everyone here probably knows the most dangerous sport. And shout outs to those people who do it, but it's a super dangerous sport. Does everyone know the most dangerous sport? Shout outs to if you're doing it, especially if you're a flyer. I would not do that. I mean, it'd be super fun, and I don't think they're doing that to me at 200 pounds. But the most dangerous sport is cheerleading. Cheerleading. I was a rugby player for a day or two. I was not a cheerleader. So don't throw me in the air. I'll splat on the ground. People have been very hurt from cheerleading. Cheerleading's great. But man, that's a dangerous sport. That's a dangerous sport. And I do think it's a sport, just personal opinions, Brian, because you're competing. That's what sport is. Sport is competition. It's who's the best. Yeah, it's competition. That's what I say. I'm throwing out those hot takes today. But it's super dangerous. If you're a flyer, you're one of the ones that they throw in the air. Woo! Woo! Careful. Be careful. So anyways, that is the chi-square test of independence. And you could do it for things like sport and broken a bone. And if you compared 5 sports and breaking a bone, how many degrees of freedom would there be? Literally trusting them with your life, right? If you compared 5 sports and breaking a bone, and you could probably draw it out. Like, here, we'll do it. There'd be 4 degrees of freedom. I'm gonna throw another sport in here. People are gonna get mad at me. Okay, so we're gonna go chess, b-ball, football, cheerleading, and soccer. And we're gonna do soccer will have 1 C. That's our soccer. That's American soccer right there. We don't know how to spell. Have you broken a bone? Yes. Have you broken a bone? No. Okay, so what do you think the relationship would look like in here? The decision to start hot takes with Brian. I talk to people on Ped Walkway and share my personal opinions, but I don't go more hot take personal opinions here. It's spelled with 1 C, Elizabeth. American spell in soccer. Here's what I think the relationship would look like. And I play chess. I think it's gonna look something like this. We'll just pretend like this is the only sport you play. Like people only play this sport. So Hakuru is that we got like Gotham chess and all those in Hakuru over there in chess. B-ball, basketball, football, cheerleading, soccer. Does that make sense on this mosaic plot that I drew? Showing you the relationship. It doesn't always have to go in order. Sometimes it's nice if we put it in order. But does that make sense on the relationship between breaking a bone and primary sport someone plays? I don't know what my primary... I was on cross-country, swimming, track, wrestling. Do you think I broke a bone? Take your answer now as we get ready and go to leaderboard. Has Brian broken a bone? Let's do a vote real quick on that. Has Brian broken a bone? Do you think Brian's broken a bone? He played cross-country track, wrestling, swimming. In that order were my primary sports. Okay, leaderboard: Inspired Lobster, Elated Badger, Groovy Finch, Silly Swan, and Fast Goat. To the answer to the question, I have broken a bone, but I was riding my bike with no hands and went around a corner and flew off and hit the ground like that, because you want to make sure you roll, and I rolled and hit, and I broke my arm. I think it was my right arm. Okay, let's go to the next question. Here we go. What is the null for this test? If you listen closely, you should get it. The mosaic plot is the visualization of the chi-squared test of independence. Not playing sports. I didn't actually break a bone while playing sports. I did bust a guy's nose with wrestling with a crossface when I was, starting top, and I went boom like that with a crossface. I didn't rear back. Someone's watching my arm. They're like, man, you went way back. You were like, wah, around the world on his cross. No. Sorry, we'll get serious this time. Okay, for the chi-squared test of independence for the null hypothesis, you just write independent between them. So we just reviewed this a moment ago. Well, darn it, pretend you didn't see me click on the answer. Or you did see me click on the answer. But the chi-squared test of independence always, oh no, I'm sorry, Ronak. I'm sorry, that probably wasn't me. Shout out to Ronak right there. Yeah, man, crossface. Moira, we shout out your review in Stokely coming up, or Stokely, right? Or is it in No, it's with strong, right? Strong, I've got it right here. Strong B1. Moira's review at 2. We're going to try to end with like 15 minutes before that, pinning it again. Everyone, let's throw some 5,000 points to Moira. I'm going to get a little more serious here. I'm having too much fun. But throw some W's for Moira. Go check out Moira's review here. Pinned in the chat again. 2 to 4:30. W Moira. She's written her practice test. Lots of great questions. I took a look over it. Really hard work right there from one of our best SI leaders ever. So shout out to Moira. What is the trick for the chi-square test of independence, which pretty much everyone got right here? When writing the null hypothesis, just put what between the two words? When writing out the null hypothesis, just put what between the two words? When writing the null hypothesis, just put independent. Breaking a bone is independent of gender. The alternative hypothesis is breaking a bone is not independent of gender. And we did see another example where I drew it out and I showed you, I think we still have that one open, what it would look like. Let me ask you, what do you think the p-value would be here? High or low? What do you think, high or low? Say high or low in the chat. It would depend on sample sizes. I've seen some questions where, yeah, on the test, we usually do independent. Good job, Rob, right there. Oh, the p-value would be so low. And don't worry if you said high. The p-value would be so low because there's big differences here that are unlikely by random chance. So that right here, this would have a low p-value because of the big differences. Adam, we're throwing you more points. Good answers. Keep it up. We would think low p-value and evidence that they are not independent. And as Nirav is pointing out right there, you could also say that they're associated or evidence that they're associated. So the null can also be no association. No association is the same thing as independent. And how would this look if they were independent? Probably, and you would expect, we shouldn't say assume because sample sizes come into play. We would say we would expect if it looked more flat across that this would have a high p-value. And you can't say well, if it's perfectly flat as a p-value of 1. This would have a higher p-value, and this has big differences that are unlikely by random chance and low p-value evidence of an association. Does that make sense? And good questions right there. Excellent work. Moira's got her review posted. We'll go on to the leaderboard. We got Inspired Lobster, Elated Badger, Groovy Finch, and Fast Goat, and Bright Bunny. Bunnies, we love bunnies here. Next question. What is the alternative for this test? Nice and easy. You should get it. I put a lot of time on these, but remember, if you're just saying, I think I did it. Yeah, I made it too easy. Actually, I think I had a little bit of fun with this because what do you notice? I hope I did it correct. I'm very sorry if I messed this up, but what do you notice about the answers? Take a moment and look over all the answers if you've already answered, but tell me something you notice about all the answers. What do you notice? That there are actually what? There's actually, is it a multiple select? If I did a multiple select, I did this question correct. So remember, when we are testing with the chi-square test of independence, the null is that they are independent. The alternative is that they're not independent, but there's other ways to say that. Not independent. Like if I say to you, my wife drinking coffee is not independent of me drinking coffee, what am I telling you? There are 2 right answers, unless there's a third that I don't see. If I say Brian's wife is not independent of Brian drinking coffee, what does that mean? It's associated. That somehow me drinking coffee would imply the likelihood of her drinking coffee is higher or lower. Same thing with gender and breaking a bone. That somehow knowing someone's gender would imply a likelihood of them breaking a bone or not. Doesn't mean they will break a bone or won't break a bone. It just means it might be more or less likely. And we do see the association here that males are more likely to break a bone, and that is correct. That associated. Now be careful. The mean of gender. Now, when do we use means? When data is quantitative. So there's nothing dealing with means right here because for the chi-square test of independence, both variables are what? There's nothing dealing with means. And this is a great review because for the chi-square test of independence, both variables are what? Categorical. So nothing dealing with means. And this one also says means, so that's wrong too. But don't worry if you got it wrong. Cat's in the chat. Here we go with the leaderboard. Inspired Lobster, Elated Badger, Groovy Finch, Giving Tiger, and Inspired Iguana. I miss bunnies. Next question, let's do it. Find the missing value. Have your equation sheet out. So what missing value are you trying to find? You are trying to find a what value. This is the way the test looks. You are trying to find a what value. You're like, wait, what? I got to find this? The expected count. And you know that because the first is the count, the second's the expected, and the next is the cell chi-squared. This is where you go to your formula sheet, which I'll do right now. And on your formula sheet, you find the formula that says what? What formula do you find on the formula sheet right now? If you are on your formula sheet, what formula would you see to find expected cell count? You go to your formula sheet, and you go down here and you see what formula. To find expected cell count, you see what? What formula would you find? Right there. Row total times column total over grand totaling. Either or. Kaylin, either or. We accept them. And so how in the world would you solve that for this? Write the equation in the chat, see if you can get it. Who has it? What would the equation be? If I look at this right here, 261, the answer is going to be this. And great job, Caitlin. How did I get that answer, though? Do you know how I did it? I know something. I know a trick. Let me show you the right way to math it out first. Use the right math formulas first, and then I'll show you a trick. So the shortcut, right, Noah? So here's the right way. If you're trying to get an expected cell count, do the crosshair technique. Go across, crosshair, down, crosshair. Notice it crosses over that. Then divide by the grand total. So there's the formula, which we see in the chat. But here's something you should know. That expected cell counts, yes, Elizabeth knows the trick also. That these two values right here, if you add them up, have to equal this. So you can just call this X. And then 421 minus 159.105 equals X. So it's because expected cell counts have to equal the totals by which they add up to. So that's just a trick right there. I wouldn't do this first. It's just a way to check your math that if you put a value inside of here, it would have to sum up correctly to the values. So that's just an additional check. Don't use it unless you've solved it first and then check your work, or if you're short on time, use the shortcut method. So good work. Let's do the next calculation question. Have your formula sheet out. Here we go with the leaderboard. Let's do the question. Here we go. Find the missing value. Here we are. Okay, what value are you missing? What value are you missing? You are missing a what? What value are you missing? This value down here is a what? This value down here, especially if you've answered, reply through, but if you're stuck, you can ask questions too. It's a cell chi-squared. So what formula do you need? What formula do you need? What formula, and you can abbreviate this. I always abbreviate when I write it. What formula do you need? It's a chi-squared test of independence. What formula do you need? Whoops, let's go back to review. You need the formula observed minus expected squared over expected. Exactly, observed minus expected squared over expected. And to find that, we have to go in and get the observed, which the observed is going to be the count of the data. The observed is the count. So we have to do O minus E over E. And the observed, a lot of people don't know this, is the count. And the expected is the expected. And here's the thing, the top of it is basically 2 squared over 132. So that's 4 over 132, which is basically a little bit less than 3%. So it's like 0.029 or something. And we could find out the exact value, but wait. Whoa. Let me check my math. Uh-oh. Okay. It's 4 squared, not 2 squared. It's 4 squared. So it's 16 over 132. That makes sense. Yeah, wow. Noah, 5,000 points in the chat. 16 over 132. Noah's put the correct math in the chat, and I didn't carry all my decimals. So Noah, let me hit the points again right here. But Noah's got all the correct math in the chat right there. And I hope I carried all the decimals when I was doing this properly. But it would be 3.895 squared divided by 131.895. There it is. And so there's the exact answer. Yeah, good work. Easy to make errors. Very easy. Write your math very carefully. And notice Noah just plugged in the values. Noah took 128. You can see the pin message minus 131.895, which is about 4. So it's about 16 because you square it and you divide by 132. So carry your decimals while doing it, though. So good work. A lot of people got it. Good practice. Next question. Inspired lobster, groovy finch, giving tiger, elated badger, and aspired iguana. Here we go. What are the degrees of freedom for the 1 sample T interval? Should be nice and easy. See if you can get it. What are the degrees of freedom? I'll put her here. What are the degrees of freedom? Nice and easy. The 1 sample T has with it what degrees of freedom? The 1 sample T, and you can look at the formula sheet. The 1 sample T has with it what degrees of freedom? What is the formula? N minus 1. Noah did it right there. You got it. Noah on fire. Everyone put some W's. Noah is on fire in the chat right there. W Noah already from Elizabeth. Because N minus 1 degrees of freedom, the complicated formula I should have said, it's too complicated because that's the 2 sample T is too complicated. The chi-squared is rows minus 1 times columns minus 1. So just memorize that right there. I like it so much. And I hope, is everyone having fun? We got more in the chat giving W's. We got Jaina here for first time and visiting and enjoying the class. Avante too. So I hope people are having fun as we go to the leaderboard here. Thank you, Narav, right there. And also, I think, for another class, but glad to have you here. So thank you so much. Inspired lobster, groovy finch, giving tiger, elated badger, stellar crane. Let's do it. You're welcome, Adam. And always good seeing you this semester. What is the missing p-value? Now, this one trips people up. We're going to draw something out here in a moment. But find the missing p-value. I've got it. So p-values have a relationship. At about 50 seconds, I'm going to start drawing. P-values have a relationship. This is the does not equals. This is the greater than. This is the less than. The does not equals is when we test to see if there's a difference or things are not equal. The greater than asks, are males taller than females? Wait a minute. No, this is GPA. I was like, why is the p-value high? This is GPA. Do males have a higher average GPA than females? And Noah, excellent work in the chat. W, Noah. Do males have a lower GPA than females? So what we should see right here is the relationships the p-values have. And let's show this. So the relationships the p-values have are as follows. Move this over here. Boop, boop, boop. Really? There we go. And up. Okay. I'll do it right here. There we go. There we go. There we go. So let's say we only knew the greater than p-value. And the greater than p-value was 15% of the curve. Actually, that should be the less than p-value. We only knew the less than p-value going in this order. And the less than p-value was 85% of the curve. What would the greater than p-value be? So type it in the chat right now to practice. If the less than p-value was 85% of the curve, what would the greater than p-value be? So I'm asking about this right here, which would be the greater than p-value. What would it be? And we're doing them in order by which they occur. They're different numbers though. It'd be 15%. Because the less than and the greater than must add up to what? The less than and the greater than, great job, Jana, and everyone else, it must add up to 1. Now, what would the does not equals test be? What would the does not equals test p-value be? The does not equals p-value test would be, great job, 0.3. Because it's 2 times the smaller. These add up to 1. Does that make sense? Not in between, though. The in between is used for confidence intervals. So notice the relationship. That means this value right here can be found a few ways. It's basically this or half of this, which leads to a decimal, which rounds up to 0.0021. And great job, Narav, right there. Excellent work and good practice. The betweens are used for confidence intervals. Good work. And so a lot of people got this. Take the p-value, cut it in half. That's one way. Or realize 0.0021 is what you get to add up right here to add up to 1. So good work. A lot of good answers. Here we go with another p-value question. Find the missing p-value. Here we go. And great job, Narav. Exactly. Yep. So how would you get this p-value right here? So it's good practice. We review things. We do them multiple times because the only way you remember things is to do them multiple times. How in the world are we going to get the does not equals p-value? Remember, we just did a cheat sheet on how to do it. So the cheat sheet shows the methods on how to get the p-values. You, Devin, I'm sorry. You know what, Devin, let's make you a mod, though. You don't get the points. Glad to have you here, Devin. Appreciate you being here, but they're how we do bonus in my class because we don't have clickers. Students can check their points. We have points. We have quotes. We have jokes. We have sayings. Oh, I'm sorry, Devin. Matchmaker Brian level. Monster Tail guy came out of the woodwork. So Bama gonna lose. Mubot there in the chat. So the way we get the two-sided test is we do double. Adam's going quote 128. What's quote 128? Quote 128 is... I'm interested in quote 128. Stat Nation point hype. If you say pints, he'll say pint hype. Or you say pointas. These would come from errors people have made when checking their points, pints and pointas. But it's funny. Pint hype, let's go. Someone typed pint hype after that. And Moira's got a ton of points and hours. Moira, how many hours do you have? I think Moira took multiple classes, right? Moira's like, how many points and hours? Moira, 60 hours. That tells you Moira was a pro right there. So continuing on, Groovy Finch, Inspired Lobster, Stellar Crane, Inspired Iguana, and Elated Badger. Next question. What is the missing T ratio? Now, we did this one earlier, so if you're here at the start of office hours or start of the review, you should get this pretty quickly. The T ratio is the difference divided by the standard error. Y bar 1 minus Y bar 2 over square root S sub 1n squared over n1 plus S sub 2 squared over n2. Yeah. Oh, you're in 320 next semester? Whoa, that's awesome. I'm excited. Man, I forgot how I'm doing 320 now because I just did honors. So Moira, that's really exciting. It's in person now, though. So to get the T ratio, who found this question really easy? Who got to this question right here and got it in moments? Remember, I said it's the difference divided by the standard error. Well, the difference is right there. This value is Y bar 1 minus Y bar 2. If we're comparing GPAs, what does this difference mean? Nice job, Elizabeth. If we're comparing GPAs, what did we see in our sample? If we are comparing GPAs, what did we see in our sample? We actually saw mean 2 was greater. So because the difference is negative, the negative difference implies evidence. That's hard. The negative difference implies evidence that the second mean was larger. Does that make sense? No worries, Noah. You're doing great. I love people who ask all the questions, give all the answers. I have good indications to do well on the test. And so there's evidence, or at least in our sample, we saw the GPA of females was 2.23 points higher than the means of males. But all we do is just do negative 0.23 divided by 0.023, and that's basically equal to what? Sample mean 2 is higher. Females were a little bit higher than males on average. So what does this equal? Negative 0.23 over 0.023. There we go. And so I want you to think about this. I am 95% confident the true difference in means of GPAs between males and females is somewhere between 0.18 to 0.28, where females are expected to have a higher mean than males because the interval is negative. Does that make sense? I am 95% confident that the true difference in the mean GPA of males and females is contained in the interval 0.18 to 0.27, where females are expected to have a higher GPA than males. You could say negative too if you want, but you can just interpret it as a positive difference. So all you have to do in this output is what these two values. All you have to do in this output is what these two values right here. These two values right here, just divide them. If you're here for the start of office hours, you're like, whoa, that's it. You just divide those two values because that first value up there is the difference and the second value is the standard error. Just divide them. Good work. A lot of people got it. Some people did. It's all right. Can you put the interpretation in the chat? Yes. Well, so look at what I'm going to write confidence in the chart here. And so, Kaylin, really good question. So listen to it and try writing it down as I say it, or other people, and I'll throw some points. I am 95% confident that the true difference in the mean GPA of males and females is contained in the interval 0.18 to 0.27. You could probably just say negative 0.18 to 0.27, negative 0.27. And that'd be it. That's it. I am 95% confident that the true difference in mean GPAs of males and females is contained in the interval negative 0.18 to negative 0.27. There we go. Good stuff. Next question. Here we go. Groovy Finch, Stellar Clay, Inspired Iguana, Elated Badger, Inspired Lobster. Here we are. What is the missing value of the difference? Ooh, a little tricky right here. What is the missing value of the difference? Now, the T ratio right here, I don't love this question. If I were to change a question on the Kahoot, I'd be like, meh, we don't need this one. If it's a proportion, we change to upper and lower to percentage. That is correct, Andrew. Times by 100, change to percentage. You are correct. I wish I had one of those in there. Maybe I'll try to do one of those examples right here. We'll do that right next, Andrew. I'll pull up a question. Sorry. We'll do that next. This question is kind of just a repeat to show you that these values have a relationship, that this over this is equal to this. Also, the previous slide, you could have seen what the value is. And if the T ratio is negative, then the difference must be negative. So that, well, darn it, they're all negative. But you know that the ratio is a basically 10 to 1 ratio because the T ratio is the ratio of this number over this number, and it's negative 10, so the difference must be negative. So you just look for the one that is 10 times the size of it, or you mathematically solve out. I don't think we've ever erased the T ratio. We've erased the T ratio. I don't think we've ever erased the difference. And so good work right there. But I'm going to do a proportionate interval for Andrew. Good question on that. And so which of these could I do a proportionate interval on? Tell me one of these to do a proportionate interval on. You tell me, and I'll do a proportionate interval to estimate the true proportion. There we go. Which one of these could I do a proportionate interval on to estimate the true proportion? Pick one of these right here. Which of these could I do a proportion interval on? So which one of these could I do a proportion interval on? Any of these variables? When would we use a proportion interval? When the data is categorical. Let's do born in Tennessee. So we go analyze distribution, born in Tennessee, and then we go here, stack it to make it nice to read, confidence interval 90%. So let's say we want to analyze if students are born in Tennessee. So what would we do? How would we interpret this interval on the screen? We want to know if students are born in Tennessee. Interpret the full interval for me. We want to interpret whether or not students are born in Tennessee. Interpret the full interval for me. How do we interpret that? And great job, Andrew, was pointing out the lower and the upper. So how do we interpret this? I am blank percent confident that the true blank is contained in the interval blank to blank. And you can change it to a percent. And I really love writing these out. If you're watching this in the future and I'm pausing, this is an excellent chance to grab a sheet of paper and write this out. The more you write, the more you say it, the better you understand it. And what do we have? We'll probably have some answers here in a moment. I am blank percent confident that the true blank is contained in the interval blank to blank. Get a little worried when the chat pauses. I am 90% confident the true proportion of students born in Tennessee is contained in the interval 0.56 to 0.61. Exactly. And that'd be a margin of error of basically 0.025, because you can see right here this 0.0858. So I'm rounding it, 585, sure, plus or minus 0.025. There it is. There it is right there. Horrible handwriting and all. I'm 95% confident. Not the true mean, though. Not the true mean, though. True proportion. True proportion. Good answers. Merit is true proportion because are you born in Tennessee or are you not born in Tennessee? No worries. I am 90% confident that the true proportion of students born in Tennessee is contained in the interval 55.7% to 61.03%. A lot of decimals right there. I am 90% confident that the true proportion of students born in Tennessee is contained in the interval lower to upper. Categorical is proportions. Good job right there. And Molly, great work too. Next, leaderboard, Groovy, Finch, Inspired Iguana, Stellar Crane, Elated Badger, and Giving Tiger. Next question. What is the null hypothesis for this test? Okay. Now, there's a very easy way to remember this. The null has the what? The null has the what? The null has the what? This is, I swear, like 90% of people get this because, yeah, the null has the equal sign. The null has the equal sign. You can frankly just put the equal sign between them and say they're equal. So you can go right here and say male equal female, mu male equal mu female. How do we decide the alternative? Do we look at the data or do we look at what the researcher's questioning? So do we go out and collect data and then decide an alternative to figure out if we have evidence for? Or do we come up with a researcher question and then collect data? We look at the researcher's question first. The researcher says, I want to understand this and research this, and then they come up with their question and then they collect data. Data is collected after researchers come up with questions because you don't let the data dictate what your research is doing. And I hate to say it, that's bad research, and we do have bad research. The personal opinions with Brian. The problem with science is not science. The problem with science is bad science. So if someone collects 50 variables and then tries to find relationships that exist, they're doing what is called p-hacking. Because your type 1 error rate is 0.05, and if you run a bunch of tests, you will get type 1 errors, false positives. So we need better science to replace bad science. So I always get mad when people are mean to science and they're like, oh, well, science thought this at one time. Well, good thing science is self-correcting. The solution to science is just more science, because science is just the investigation of phenomenon in the natural physical world, and we can do that with data. Give me data, let me investigate it, and make decisions. And the better you collect data, the better you can analyze things. And more self-aware scientists. P-hacking is bad scientists. John Oliver has a really good section on this. Check out John Oliver, P-hacking. He goes into detail on what it is. It's PG-13-ish. I don't know. If you are random person put it, just Google John Oliver P-hacking, you'll find it. He had a good section on it, what P-hacking is. Don't do it. Don't cheat your results. Groovy Finch, Inspired Iguana, Stellar Crane, Elated Badger, Giving Tiger. Next question. Here we go. What is the alternative hypothesis for the two-sided test? So what is the alternative hypothesis for the two-sided test? Now, there are three types of alternatives: the less than, the greater than, or the not equals to. And we call them sometimes tails. So we did a drawing a little while ago where the less than shades to the left, the greater than shades to the right. You think it's like a greater than, it's gonna just, it eats the bigger value, but it shades to the right, and less than, being a little less than symbol right there, shades to the left. The does not equals shades both ways, and we call it the two-sided or two-tailed test. Now, that's not a two sample T. Can anyone explain to me? This is really hard to explain, but if you know it, you know it. When would we have something like a one-sided two sample T? When would we have a one-sided two sample T? We could do it with this output. When would we have a one-sided two sample T? I'll answer at 20 seconds. When would we have a one-sided two sample T? Does anyone know? Yes, Kylie, 5,000 points to see if one mean is greater than the other. Exactly. When we have two means we're comparing, because that means two sample T. That's what a two sample T is. And then one-sided means maybe we want to see if males have a higher GPA than females. And no, they don't. Sorry, I didn't help out with that. But this is the alternative hypothesis, male greater than female, if you put the greater than sign right there. So Kylie said it perfectly. When we want to see if one mean is greater than the other, because that means we have two means, two sample T, and we're doing a directional test, a tail, like one tail, one direction. So Kylie, perfect answer right there. We'll throw you another 5,000 points because those are the answers we want to hear right there, that a two sample T, one-tailed or one-sided. Tails are called the sides of a test. Like one-sided is one-tailed. And there's two one-sided tests and one two-sided test. Next question with Groovy Finch, Inspired Iguana, Elated Badger, Stellar Crane, and Giving Tiger. Here we go. Interpret the difference. What does this difference mean? I interpreted it earlier, but remember, the difference is negative. And be careful. What words are words you would not use here? Because when you're doing the t-test, you know him, you love him, but he's very what? Because you're comparing quantitative stuff. You should be able to narrow this down pretty quickly. You should be able to narrow this down to two answers. Because you should know the t-test always deals with quantitative data, so you're dealing with means. And you can see here the difference was found to be what? In your sample data, Mr. T is mean if you're doing drugs. Says, I pay the fool. I pay the fool who doesn't know about the test. So in the difference, it is negative. And since the difference is negative, that means what? Great job, Caitlin. Since it's negative, the second group was higher, had a higher mean in the sample. This difference right here is the subtraction of these numbers. And since it's negative, females were higher. So good work. You see what I said? We had over 50 people. We've lost 30 to 35% of players. No, it happens every Kahoot. I understand people come in who maybe only have a limited amount of time. And thank you for being here. I'm hoping it's the people who, maybe all the people who are winning left, because I told them, they're like, I've already answered 10 questions right. I don't need to be here. So. Oh, I need my sad music. Where's my sad music? I gotta grab my card. Is that sad music? Probably not. We have a lower GPA and we had to break more bones. Oh no, Avante, that is true. Avante, 5,000 points. Us males have lower GPAs but breaking bones. That's the way it goes. It's the life of a male. Here we go. Groovy Finch, Stellar Crane, Elated Badger, Inspired Iguana, Giving Tiger, and Avante, we are giving you a quote of the day. We haven't done this yet, but Avante has quote number 491, quote of the day in forever in Stats 1 history. Oh, no worries, Jaina. Thank you for being here. We're going to do a few more questions, so you'll get to be here for at least one more with this one. Story time, what is the type 1 error? Here we go. So you're walking through the woods, and, there's a lot of twigs out there. You see them, and they're like, whoa, that's a snake. So what happened when you saw something and you thought it was a snake, but it's not a snake? So did everyone hear that? The null hypothesis is that everything in the woods is just woods. Like that's a twig, but wait a minute, and you look and you're like, that's a snake. But the thing is you step on it and it goes crackle, crackle, like a twig would. You're like, is that a big snake right there? And you accidentally step on it, like as you're thinking it and you're freaking out, but it goes crackle, crackle. So what did you have? You had a false what? So I think the null is that it's a twig. So you had a what actually? You had a what? What did you have? Does anyone know? You had a false positive. A false positive. So a false positive is when the test comes back rejecting the null. But the thing is, we call it a false positive because in a type 1 error, the null is what? In a type 1 error, the null is what? In a type 1 error, the null is true. So state to me again, if the null is true, then that thing is a what on the ground? Look at the null. So if the null is true, then that thing is a what? If the null is true, then it is a what? In type 1 error, the null is true. So it is a twig, but what do you do? So in a type 1 error, the null is true, but you what it? but you what it? You reject it. So it's a fact of the world that that's just a twig on the ground. But you think, oh my gosh, and you think it's a snake. So you think it's a snake, but it's not. Did everyone hear that? You think it's a snake, but it's not. Because in a type 1 error, the null is true. It's a fact of the world that that's just a twig. Does that make sense what the null is true means? That's not up for debate. And you make errors by accident. You don't know you make them unless you like step on it and you're like, oh, it turns out. Like imagine you had a false positive and you ran out of the woods screaming. Do you think anyone's ever ran out of the woods screaming because they thought they saw a snake and it wasn't a snake? And Caitlin gets it. Do you think anyone's ever like been in the woods and they see something and they're like, oh, and then they just run out? And then it's like, it turns out that was just a piece of wood. You got false positived. So in a type 1 error, the null is true. So what would a false negative mean? You're walking through the woods. What does a false negative mean? And you're just stepping on things. And you're like, just stepping on things left and right. And you're like, oh, I'll just step right here. You're just like, you see it, and you're like, I'll step on that. What does false negative mean? You're just like walking through the woods and you're like, you have a false negative type 2 error. You step on this right here. So basically, exactly, in a type 2 error, the null is false, but you fail to reject it. It's the reverse, because if the null is false, then it's not a twig, but you don't reject the null. So you're going to be like, oh, I don't reject the null. That's a twig. I don't reject the null. And then the null is false. You step on it and it goes, and you're like, ah, false negative. Oh my gosh, why don't I turn up my alpha level and reject the null more? That's what statistician would say. So false negative, false positive, type 1, false positive, type 2, false negative. Let's do another story time with Brian here. So if you have time, one more story time with Brian. Okay, the null hypothesis is the tree is healthy. What the heck happened here? So remember, the null is that the tree is healthy. So if you were outside and you were looking at your trees, you'd think, man, all my trees look nice and healthy. Now, of course, we saw that storms can knock down pretty much any tree, unhealthy or healthy, but we'll pretend there was no storm, that this was just natural course of nature for this tree. So you think your tree is healthy as the null hypothesis, and then the next morning you wake up and there was no storm, but this happened right here. So what error would have occurred? So think, what did you do to your null when you looked at that tree? What did you do with your null when you looked at that tree? You looked at that tree the day before and you thought, "Mira, there's no storm coming." You're just looking at the tree and you go, "I what my null?" Because you got your chainsaw, you're like, and you do what to your null? You rejected the null? Well, that means you would do what? If you reject the null, you would do what? Technically, someone with bad skills might have rejected the null here. Technically, we'll pretend this is, they woke up and saw this. You fail to reject the null. Because if you fail to reject the null, you believe the tree is what? If you fail to reject the null, you believe the tree is what? If you fail to reject the null, think, you look at your null and you say, my null tree is healthy, and you say, I don't reject that. You believe it's healthy. But in a type 2 error, the null is what? In a type 2 error, the null is what? So in a type 2 error, the null is what? Because we fail to reject the null, and the null is what? False. So just look at that null and think, if the null is false, then the tree is what? If the null is false, then the tree is what? If the null is false, then the tree is not healthy. Because the null is that the tree is healthy. We're not going to reject that. We're going to believe the tree is healthy, but the tree is not healthy because the null is false. And so that means you leave the tree up and it falls. Because you're like, I think the tree is healthy. But the null is false, the tree is unhealthy, so you're wrong. You made a type 2 error, a false negative. Now, what would a type 1 error be? You got your chainsaw out. You got your chainsaw out. What does a type 1 error mean? What are you doing if you're doing a bunch of type 1 errors? You type 1 error your whole lawn. What would it, if someone type 1 errors their whole lawn, Molly sees it. They'd cut down all their healthy trees. They're like, man, this guy is going to type 1 error the whole lawn right here. You're welcome, Jaina. Good to see you here. Have a nice day. No more trees. No more healthy trees. Now, you can make the right decision. Like, you could cut down an unhealthy tree or leave up a healthy tree, which would be correctly rejecting the null or correctly failing to reject the null. And that gets into the idea of statistical power. And probably people with better statistical power would have had larger sample sizes. Like, people have done this a lot, like looked at trees more. So if you were to make type 1 errors, you would cut down healthy trees because the null is true and you reject it. A type 2 error, the null is false, so the tree is sick, but you fail to reject it, so you believe the tree is healthy. So in a type 1 error in this instance, the person cuts down healthy trees. In a type 2 error, they leave up sick trees. Here we go. Last few questions. Groovy Finch, Inspired Iguana. Remember, email me if you win. There are, I should have maybe said that before Jana left. There are Starbucks gift cards or Amazon gift cards. Please say which one you want in your email. Hey, Brian, I came in first, second, or third. I would like a Starbucks or Amazon $20 gift card. Let's do this right here. When doing a 2 sample t-test, the variables will be what? We already said this at the start. See if you remember it. When doing a 2 sample t-test. So let's take a look. Here's a trick question. We don't really use identifiers. So the 2 sample t-test would not use identifiers because we rarely to never visualize or do tests with identifiers. They pretty much just identify. When you have 2 quantitative variables, you're doing what? Does anyone remember QQ straight enough? No outliers, plot doesn't thicken. When you have 2 quantitative variables, you're doing what? Does anyone remember QQ straight enough? No outliers, plot doesn't thicken. So what are you doing if you're doing that? QQ straight enough. Regression. That's the conditions. QQ straight enough. No outliers. Plot doesn't thicken. Both quantitative variables. So that's when you're doing regression or correlation. Just depends if you want to fit a line or not. How about both categorical? When do you have both categorical variables? That's when you're doing what? So this would be regression. This would be we don't do that. Both categorical would be what? Which isn't the answer. There's the answer here. Both categorical would be what? A lot of people say both quantitative. It's the most common wrong answer. Chi-squared. Chi-squared requires count data, both categorical. Most common miss is this right here, so I went to it first. That's regression or correlation. That's chi-squared. And when you're comparing the means of 2 groups, so the categorical creates the groups, and it's the levels are like male, female, or undergrad or graduate, whatever. And the quantitative is like height, weight right there. So there we go. Next question. Groovy Finch, Inspired Iguana, Stellar Crane, Elated Badger, Charming Chicken. 2 quantitative variables is regression. QQ straight enough, no outliers, plot doesn't thicken. The conditions for regression. When working with statistical power, which of the following do we have the most control over? Think most control over. There are other ones we have control over, but which of these do we have the most control over? So, what are these things? We have alpha. Alpha is when you reject the null. Unless otherwise stated, alpha is considered to be 0.05. The researcher picks their alpha level. Alpha is literally your type 1 error rate. So if I say my alpha is 0.10, higher alpha, more type 1 error. Alpha controls beta. It is inversely related, as in higher alpha is lower beta. Beta is your type 2 error rate. So more type 1 error, less type 2 error. Effect size is the impact or the actual difference between the null and the truth. So if you have something like Brian versus Darren in basketball skill, we might be that far apart. Or if you have Brian versus his friend LeBron, that's a bigger effect, which is the difference that Brian and LeBron are the same to the actual difference that Brian and LeBron are very different. Of course, LeBron's way better. So when there's a bigger effect size, we make less type 2 errors. So effect size is inversely related also to type 2 error. Sample size is going to be how much data we take. You could watch Brian and LeBron play for a minute or an hour. If you have a bigger sample size, you make less type 2 error. Notice that all of these are inversely related with type 2 error. So which of these would you have the biggest impact or control over? The answer is technically 2 of them. The one researchers usually like to work with the most is how long do we watch that basketball game for, but also alpha level. You can control your alpha level to any degree. Sample size is probably the best to change though, because sample size, more statistical power, and you don't really control beta. Beta is calculated from these. So one could say, well, if I increase my sample size, I decrease my beta. Okay, sure, but your beta is calculated from the other metrics also, and you don't control effect size. So don't worry if you answered effect size. That's the one you have the least control over, because you don't control how much better LeBron is than Brian. I wish I could and get better at basketball, but that's not happening. I'm 6'3" and I can't play basketball. I can, but you don't want to see it. And alpha level right there is the point at which you reject the null, your type 1 error rate. It's best to keep it at 0.05. You can change it. And then if you do increase it, you increase your what? Increasing alpha directly increases your what? Write this in the chat to see if you remember it. Write it down if you don't. Increasing your alpha directly increases your what? You increase your alpha, you have increased your what? Because alpha literally is this. You increase your alpha, you have directly increased your what? No. I actually know Zach Doherty. I think it's Zach Doherty who's with the UT. He does analytics, and he would say no. What is related to that, Noah? 1 minus alpha can be related to confidence level. But let's write this out. I was debating it. It will impact power. So it won't impact effect size so much. We drew this out in class, but here's sample size, alpha, and effect size. Alpha is literally your type 1 error rate. Whatever you call alpha is how much type 1 error you make. So whatever you say alpha is literally your type 1 error rate. Molly, you got it right there. And if you increase type 1 error, you do what to type 2 error? If you increase type 1 error, you do what to type 2 error? If you increase type 1 error rate, you decrease it. But why would power go up? Why would power go up? Because power is the what of type 2 error. Power is the what. Think of a C word we came up with a long time ago in stats. Power is the what of type 2 error. It's complementary, right? It's a complement. So it's 1 minus. So what happens if you increase alpha? Test is more powerful. What happens if you increase sample size? Test is more powerful. Power is the ability, write this down. Power is the ability to correctly reject the false null. I'm actually gonna put a quote from Ubot in here. It needs to be a command. So okay. Mubot now knows about power. We shouldn't have probably told him that. So power is what? It's the ability to correctly reject the false null. So Mubot's going to reply to me. Probably I should have put my name on that. Let me do, is it name? I'll worry about that later. Be fun. He can tag you. But does everyone write this down if you haven't? Any questions about what I have on the screen right here? Effect size is the true difference between the null and the truth, or the actual difference. Like, it's easier to detect differences when the effect size is larger. Like if you measure Brian versus LeBron, it'll be easier to see the difference between me and LeBron versus me and Darren, because there's a smaller effect between me and Darren. Or if you're trying to see, what increases your salary the most, and maybe you, I don't know, take courses in stats, and stats courses really help and give you better quality of life. I would love that. We'd have to look, and if stats have a big effect, the test would be more powerful and easier to reject the false null. So the type 1 error would be affected by, we would be more correct in rejecting the null. So the type 1 error is literally your alpha rate. So here's the thing. You can make a test more powerful by rejecting the null all the time. If we wanted to find all the trees that are sick, what could we do to our yard to find all the trees that are sick? If we wanted to find all the trees that were sick, what could we do to our yard? If we wanted to find all the trees that are sick, what could we do to our beautiful yard right here? Cut down all the trees. Oh, we just go here and just go. this would be easy. These little trees right here. And think about this. So now we have a lot of what's though. Like because we've increased our alpha and now we don't have any problems. We found all the sick trees. We had a very powerful test. We found all the sick trees. Like we're trying to reject the null when the null is false. So we're trying to find the sick trees because the power of the test is the ability to find sick trees. This test will find all the sick trees at the expense of what? That test will find all the sick trees. So the test is very powerful. It found every single sick tree in my yard. Maybe there wasn't even any. It found all the sick trees at the expense of what? All the healthy ones. And did I make any type 2 errors with my yard? Did I make a single type 2 error? Because type 2 error would be leaving up a sick tree. So think by cutting down all my trees, even the healthy ones, I probably just made a lot of type 1 errors. Now I can't make type 2 errors. So now we can't make... And the effect size for a sick tree, what would the effect size for a sick tree look like? So the effect size for a sick tree would be if you go out to your yard and which of these trees right here, let's pretend we know we have superpowers and we know that both these trees are sick somehow. We know that. And with our superpowers, we know that both these trees on this image are sick right here. So the null is technically false for both of them. Where'd my extra image go? Did it not show up? Well, I guess I'll take a picture. So with our superpowers, somehow we know both these trees I'm about to show you are sick. But which of these has a bigger effect? Like, just hypothesizing. We know somehow with superpowers, both these trees are sick. But where's the bigger effect? Like, at least conceptually. Which tree has a bigger effect on being sick? The effect is the true difference. Like, the null is that they're healthy. Apparently, they're both sick, but one's only a little sick. That's a bigger effect right there. I can see that very easily with my eyes. I'm not even a tree person. I'm like, that tree's not doing well. So which of these would you have an error on, and what would the error be? Both these trees are sick. That's a fact of the world. The null is false. A fact of the world is the null is false. So which of these would you have an error on, and why? Which of these, so healthy tree, which of these would you have an error on, and why? Does anyone know? Tree 1 or tree 2? The fact of the world, which somehow we don't know right now, but it's a fact, is that both these trees are sick. Both these trees are very sick. One's a little more sick than the other. But which of these would you have an error on, and why? Exactly, Molly's seeing it correct. Well, and then so we're saying somehow it's a fact that both these trees are sick. Like, that's just a fact. Like, the null is false. So this is the tree right down here. Tree 2 is the tree you would leave up and it would fall. Does that make sense? This is the tree, because of the larger effect, you would chop down and reject the null on. Anyone's going to look at, or you just were not good at your housekeeping or lawn keeping and said, I'm going to leave that up. And everyone's like, you're crazy. Reject the null. Chop down the tree. Reject the null. Tree's not healthy. Reject the null. And this one, you apparently didn't know it was sick. You didn't have enough evidence due to the small effect size. But the larger the effect size, the less like you are to make a type 2 error. The more power you have, the ability to correctly reject the false null, which is the complement of type 2 error. Good review. Check out the lectures. We only got so much time here. Last few questions. People thinking. So, Groovy Finch, Inspired Iguana, Stellar Crane, Elated Badger, Charming Chicken. So, effect size is the true difference between the null and the truth. As in, like, think about where's there a bigger effect between Brian and his brother in basketball skill or Brian and LeBron? The null is that we have the same basketball skill, and the effect is something that exists, like our true difference. So where would the bigger true difference be between Brian and his brother or Brian and LeBron in the effect of basketball skill? So the effect size is the true difference between the null and the truth. So the null is that Brian's the same as LeBron. The null is Brian's the same as Darren. So where do you think, and my brother's not in the NBA just for reference, where do you think, nor am I, where do you think the bigger effect size is? The bigger effect size would be between Brian and LeBron, because the skill level would be much more different. And that's the effect right there. So making a type 2 error and type 1 are context dependent. Exactly how far, it's the truth, which we may never know, Avante. We may never know the truth. We just have estimates of it. So if you think about like maybe you have where's the bigger effect size in people's cooking talents if we go and we test people at a culinary academy versus a high schooler, or we test like your mom's cooking versus culinary academy. Your mom, there might be a smaller effect size. Culinary people are great, but we all love our moms, and so there might be a smaller effect size. Our moms might even win that. So the effect size is the true difference between whatever we're measuring, and oftentimes we assume that they're the same. And imagine we test one high schooler versus another. We might detect no difference when there actually is one, and we would have a type 2 error, and we wouldn't detect that the high schoolers are different in their cooking skills because they're so close that it's hard to detect that small of a difference. So the effect size is the actual difference that exists, which we don't really know. So that's the thing you can't control. You could control how many dishes you try by them, so you could increase the power of your test by having them cook more dishes for you. Maybe they're your brother and sister and they're in high school. You're just like, I need you to cook me dishes for a year, and then I will figure out who's the better person, because the effect size here is so small, I need a quite large sample size. Or you could just reject the null after one dish with a high alpha level, and that'd be bad stats. Calculate the degrees of freedom for freshman, sophomore, junior, senior, and owning a bunny. What are the degrees of freedom? Good bunny. Treat your pets well. Give them lots of love and care. That's what I say. Kind of. I can only do so much with Kahoot because there's all multiple choice, or there's numeric stuff, but we've covered a lot of concepts, Parker. This one's got a quick trick to it, and head over to Moira's review after this. What are the dimensions of this table which determine the degrees of freedom? Bunny. What are the dimensions? This is a what by what table. You do your trick 4 by 2. So all you do, and do not use the totals. Do not use the totals. If you see a table, do not use the totals. To review, what are the dimensions of this table on the screen here? So everyone's doing the one on the screen, right? This is what you might see on the test. What's the dimensions of that? Be careful. Don't use the totals. Jasmine's already got the answers to degrees of freedom. What's the dimensions, though? You got it, Jasmine. Good answers. 2 by 2. Don't use the totals. 2 by 2, drop by 1. 1 times 1, Nick, good answers. So it's a 2 by 2, 1 degree of freedom right there. Just don't use the totals. Most common error right there is using the totals. Degrees of freedom are rows minus 1 times columns minus 1. Last question of the semester. Let's see what it is. Groovy Finch, Inspired Iguana, Elated Badger, Bright Bunny. Let's have our special guest post this one.
You didn't even have my voice ready? Come on. I'm Tiny Brian! Okay, here we go. How could someone make this test more powerful? Like me. Powerful Tiny Brian. What could you do? 120 seconds, too long for Tiny Brian.
What can we do to make a test more powerful? Is this a multi-select? Might be a if it's not a multi-select, the answer is very simple. What things do we control the most? Well, it's not, then the answer is so simple. So what do we control the most when doing power? When doing power, what do we control the most? Sample size and alpha. Great job, Drew. Drew, what is proper statistical methods to alter your alpha, which is your directly type 1 error rate, or collect more data? Probably less than 10% of the data set, or less than 10% of the population. What is better stats to collect more data, or to alter your alpha and just reject the null more, to reject the null to make a test more powerful? Better statistics is definitely to collect a larger sample. And do remember this relationship right here, to collect more data. Your alpha level is your type 1 error rate. Your beta is your type 2 error rate. Now, alpha is related to confidence intervals, so you do have the relationship that increasing alpha would lead to like a 10% alpha leads to a 90% confidence interval with the analogous test. And it's a two-tailed test. That's another fact of the world just to know for this test, that if we said like, what is the analogous confidence interval of an alpha of 0.06? 94%. But alpha is your type 1 error rate. So it's literally what percent of the time you make type 1 errors. And is your sample size how much data you collected. Effect size is the true difference between the null and the truth, or differences we see. Increasing sample, because increasing alpha can increase more type 1 errors. Exactly. And so sample size, if you can, helps you get more data. Before you go, can you go over the makeup of the exam? Are there short answer questions? Yeah, let's finish with that, Kaylin. Good question. And Avante, great work. W Avante, let's throw you some points. Let's announce the winners here. The winners are Groovy Finch, Inspired Iguana, Elated Badger, and I'm interested to see who wins. Make sure to email me, bstevens@utk.edu. Make sure you say I was in first, second, third, but make sure you also say I'd like a Starbucks, I'd like a Starbucks, or I'd like a Amazon gift card. Let's talk about the makeup of the test just briefly here. So for the test, and swing by Morris Review here in Strong. So run over there right now if you can. The makeup of the test is like Canvas content. It has multiple choice. It has true, false. It has fill in the blank where we like leave a word out. It has output where you're missing numbers. Every Canvas content you're doing, some of those Canvas contents literally have test questions that are stolen from them for the test. The last 12 points on the test are going to be confidence interval interpretations and test interpretations. So know how to write this out right here. Confidence interval interpretations and hypothesis test interpretations. Write those out. Also review the lectures. And I cannot state this enough, that using review 3 right here, watch the videos. This is the last thing I'll say, because really this right here, these videos, which are barely watched right now, it's all right. I'm not sad. I might, Abby, I might. It's a busy week. These videos, I go over the full test, all the notation. So I go over every bit of notation. I explain the notation. I explain when we use it. I write out an example problem. I solve through it. I do the conditions. I show all the math. Everything's solved. I show the degrees of freedom. I calculate the values. I use an applet we used to use. I show you the p-value, and I run the test. That's 4 years ago. I was looking. Did I look at the camera over? Is that 4 years ago or 5 years ago? What's up, Brian? Pass, Brian. Pass, Brian. Thank you, Drew. I'm actually, am I wearing? No, I'm not wearing the same shirt. It's a V-neck shirt. That's a V-neck shirt. I can't see the screen. That is me constantly looking at the screen right there. Like I'm like, I can't see the screen. I can't see the screen. I can't see it. I'll show you a memory lane thing right here real quick. No, it's 4 years ago. That was, yeah, it's December. Oh my, it is exactly 4 years ago on the dot. I came in to make these videos. Would you suggest the test 3 concept review or test 3 speedruns first? Probably go speedruns. They're all really good. Speedruns, I like speedruns best probably. Thank you so much, Jolly right there. So like the name, good name. And videos. Oh, these aren't, oh, there's these. Here's the Joker video. How many people saw this video this semester? Got to see me as the Joker if you watch this video. I was like, why not? Let's just do a video as the Joker. Just why not? A lot of hidden gems on the channel. It was really fun. If you go to, oh, you might not be able to see because, oh no, I can see them all because I'm here. You can't see all these because these are unlisted. So, Canvas content, chapter confidence intervals 13 and 14. That's when my hair got long again. Not too long. I've been keeping it mostly cut. Where is it? Where is it? Go back. It was Cinco de Mayo. We're almost there. I've done like 2,000 live streams or something like that. Oh, one more haircut. One more haircut. Shorter hair. Almost there. 3. There we go. Here we go. Stream right before I cut my hair. Long hair Brian. Got to my shoulders basically. It was right on my shoulders. There we go. Long hair. Kind of miss it. It's a lot though. Sometimes I just go down these memory lanes of like, yep, my hair got to my shoulders again. Just like, I've changed around the perspectives here on everything, and we got the Shure SMB7 microphone back. We didn't have this when we first came back to UT, and we have better lighting now, I think, too. If you look, my skin tone is a little more... Got to work on all this stuff. And I just want to say a huge thank you to UT. If you see everything here, what's interesting is if you go through, and especially if you go to the oldest right here, you can see how it all started. That's me streaming from my apartment. So this is my old apartment in Highland Terrace, and this is Kahoot 6 years ago, how it looked 6 years ago, and just me streaming there from my apartment. So a huge thank you to UT, just over there in a box streaming. So that's 6 years ago, and then still streaming from my apartment. How many people did we have play? I swear, is my memory off of this? Because I swear we had a ton playing. How many people do we have playing? Not that it's the same questions. Don't tell anyone that. I need to update them. No, I think I have updated some. 17. Oh wow, wow. We're doing way better. Oh, that's sad. Man, only at 17. That's review session 5 years ago. I'd stream from the classrooms. I'd bring in my computer and literally stream from the classrooms. Just it's 5 years ago. So then we had a big. What we did was we started. I guess the other streams are hidden, right? This was when we actually got it going 5 years ago, in 2019. Wow, this was the first. This September. Wow, look at that. It looks pretty good. We're streaming. I'm like trying to control myself. Yeah, it was a while ago. There we go. We had a lot of people playing in some Kahoots. So that is 5 years ago, and good stuff there 5 years ago. And then this is streaming from the studio. We had a boom mic back then. Sorry, I'm going down memory lane right now, just remembering. We had a boom mic, and I'm showing how to find p-values and all that stuff. Still got that t-shirt. It is not as bright. You're welcome. 320. Awesome, Narav. Say hey to me. You're welcome, Abby. You're seeing the history of the channel right here, basically, or what we've done. It's really thanks to Haslam, Mark Collins, Jason Greenway. What's funny or not funny, is COVID hit. You can actually see the change in the process right about here. It says January 15th, but no, we put in the studio this. This is when I was in the studio, and we actually used the microphone in the studio. So we put the microphone in the studio at an angle, and the audio got like 1 billion times better, and students loved it. Now I've got the audio on an arm. I would start with the conference roll ones. Conference roll ones are great ones to review. And then right before test 2, COVID hit. There we go. And right before I remember I came in and I was like, hey, yeah, everything's going crazy, and we'll just deal with it. And I was like, well, we'll deal with it. Which chapter is that? Chapter 13, 14. Chapter 13, 14. Chapter 13, 14. And then I was streaming from my apartment, and I put up like a curtain. Literally just hung like a curtain. I was like, well, let me hang a curtain. Like, I stapled it into the ceiling. You're welcome. You're welcome, Molly. There's 12 points of interpretations, Parker, 12 points, confidence rolls, and hypothesis tests. Julio Bourbon. There's Julio Bourbon in the chat right there. Played baseball. Streaming from my apartment. And then I redid the apartment, and I set up the green screen. So this is still my apartment, and I grew a beard for a little bit. And so this is the apartment. I gained weight. All that COVID weight. Streaming from the apartment. Interstellar. I gotta watch it. Maybe I'll watch Interstellar over break. This is literally from a 1-bedroom Highland Terrace apartment. So this is 1-bedroom Highland Terrace apartment. The lighting is a little, you can see the lighting's a little harsher. Ooh, look at that. So you get bright spots on yourself. If you look at all the bright spots on my skin, that's like your lighting's not really dispersing well over you. If you see nowadays, like my forehead's not glowing like that, versus here, like I got all these bright spots on me, and I don't know. It's really thanks to people who like teach me these things, like how to do proper lighting. Why'd I write M1? Oh, this is tree-based models for I used to stream the classes online. And then there's the interview with Julio. So huge shout outs to Julio. He did a full interview. I love that setup. And I had to set up the headphones this way. It like worked at the last moment. We got it working. So Julio did an interview with us. Very, very thankful to Julio for that. Grew out the beard. Where's the last moments of the beard? I had to get a crown. No, I had to have a little oral surgery. There's bearded Brian. As I will never grow a beard again. Probably. It didn't work. I swear, I feel like my beard, you can see my mustache is like orange. This is not stats anymore. This is memory lane with Brian. Memory lane. We're not growing a beard again. I don't care what anyone says. And then go down here. This is not that we've gone to Texas yet, right? This might actually be Texas. Let's see. Stream 4 years ago. No, this is mini term right now here because I'd shaved the beard and that's mini term. And I think we're about to hit Texas. The studio should change. And I didn't have the arm that way in Texas. So it shouldn't be there. There it is. That's Texas. You're welcome. There's Texas. We are now in Texas. And I was using I remember making the new backgrounds and stuff. That's really good. The Texas studio looked really good. I got the lighting right. We dedicated a whole room to it. Might be the color correction's not amazing. Probably I'll look at this years from now and think I need to improve it again, but trying to fix the color correction. And yeah, so that's even Kahoot has changed a little bit from that. 99 answers. And then you just go down and then, look at that color correction. Julio Bourbon. Oh, he came in and said hey to us again. So really huge thank you to everyone. Thank you so much, Elizabeth. I really enjoy doing this. It is the Kahoots and everything. Now we're back to where we were going back the other way in time. You see, I literally went to Texas, and because COVID was happening, I didn't cut my hair for like a year and a half. So I went from bearded short hair, medium short hair Brian to not cutting the hair. And this, I just saw it a second ago. I think we just saw the introduction of Morty, or yeah. I just saw it. There's Mubot. But one of them I just saw and I played Among Us. It's nice to go down memory lane. Thank you, Kayla. Aw, thank you. I appreciate it. This is fun for me in the moment to like see and remember like all these things and just be like, it's just very nice. It's been a crazy week. But wait, is this oh my gosh. Okay, I just found. Okay, wait. I forgot I did this. Oh, we did it. We got 2 points. I seriously did this. I forgot. Gosh, I miss. I gotta do some more crazy things. I gotta do some more fun. I should have put more white on my hands, but it would mess up my mic or something. It's just, you gotta have fun. If you're not having fun teaching, and then this studio, I just kind of, actually the reason I wanted to see this right here is I might be, those are so cool. Those scar things. I had 2 cameras back in the old studio. But those are actually like, you put them on your face and they like, you had to like hold them there. They're like fake tattoo type things. So you can see If you're close up, you can see it but from further away, you don't really see it. I don't know, maybe they would smooth that down in the, yeah, but it was really fun. Further away, you don't see it. I guess it could also look like bandages over your face too. You see, once you get further away, it's not as apparent, especially at that distance. But it was a lot of fun. I don't know if I show any more of the studio. I kind of just wanted to see that again. Memory lane, old studio. But yeah, thank you for whoever stayed just to hear all these memory lane talks and fun times, which we'll have more. But I appreciate everybody. Take care of you and your loved ones and your loved pets. Until then, bye for now, everybody. Outro time.
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!